مرحبا بكم. Merci d'avoir répondu à notre invitation. Cette journée scientifique s'intègre dans le cadre de notre coopération avec notre partenaire TTS. C'est justement pour, comme suite à l'émergence de certains contaminants. Et donc, on voulait donc partager avec vous donc les nouvelles techniques analytiques et les normes donc, en cours ou qui vont le devenir. Donc, pour animer cette journée, nous avons invité notre partenaire, donc Gerstel, donc un fabricant allemand. Donc, il fabrique ou il offre des solutions analytiques. Donc, il n'offre pas des instruments, mais plutôt des systèmes complets, c'est-à-dire l'instrument, la méthode et l'application et l'accompagnement aussi donc, pour ces techniques. Donc, Monsieur Peter, donc, le responsable Gerstel, Monsieur Udo, donc l'ingénieur application. Vous connaissez Monsieur Mohamed Damak, le responsable développement chez TTS. On s'excuse pour ce retard. Aussi, donc, les intervenants sont des Allemands, donc ils vont parler plutôt en anglais. Mais je suis là pour intervenir quand il faut, pour expliquer, pour vulgariser ou pour expliquer la technologie.
Assalama marhaba bikum. Juste pour vous souhaiter la bienvenue, vous êtes toujours les bienvenus à TTS. إن شاء الله الجورنيه هذه تكون تحقق الإضافة اللي تنتظروا فيها. Voilà, l'analyse des contaminants, c'est toujours une priorité nationale voire internationale. إن شاء الله à travers اليوم les présentations اللي مش يشوفوا المداخلات نتاعكم تحصل الإضافة. مرحبا بكم.
On passe la parole à M. Peter pour se présenter la société donc Gerstel.
Merci beaucoup, Nordine. Merci pour bien ici, pour l'invitation. Merci de TTS, merci des présentations électroniques pour l'introduction. Je m'appelle Peter et je travaille à Gerstel. So, excusez-moi, je ne parle pas en français très bien, mais j'essaie. C'est mon nom, Peter. C'est moi. C'est moi sans lunettes et c'est moi avec lunettes. En anglais, my work, Regional Sales Manager in the Western Europe, Middle East and Africa, WMEA area. Travaille à Gerstel in 1996. Yes, I am that old. Chemist industry, petrochemical, environmental analysis experience. This is my email address if you want to contact me. And this is about Gerstel. Who is Gerstel? What is Gerstel doing? Que faisons-nous? This is our office. We are in Germany, Allemagne. This is the office we designed ourselves. Actually, this is my window, fenêtre. This is Udo's window, ton fenêtre. And yeah, we are happy to work here. But what is Gerstel doing? So Gerstel started in 1967. And late Mr. Gerstel, because Gerstel started as a family company. And he had the idea, innovation starts in your mind with a bold idea and the courage to take a risk. What is else to succeed? And that is how he started his job, how he started the company. He grew up in Mülheim an der Ruhr, which is a city near Düsseldorf. which is our nearest airport. And now we are worldwide, globally renowned. Renowned because lately, does it work? Yes. With having, through the years, the partners, as it started with HP, the Hewitt Packard, then of course the department from HP became Agilent, and that is when we started from scratch into the building we are now. So the re-owned we are being bought by a company called AAT, Advancing Automation Together. So we belong now to this group. So Gerstel belongs now to the group that also has other companies like Scalar, Promogrom, LC Tech, you maybe heard because you're also distributing the products from LC Tech, EST, and Trace Elemental Instruments. So as this transition started by the end of last year, beginning of this year, these other companies are still new for us as well, but they are now our brothers or sisters. How do you pronounce? This is our current management. As you can see, a new managing director. One is from the gentleman, Amut, is from India. The gentleman in the down left, he is from the Netherlands, as I am. I am from the Netherlands. And here you see the upper management that is responsible for the different departments. So nowadays, the Gerstel Group is more than 220 employees worldwide. So over the world, we have different offices. You can see in the next slide where we are located, and over 70% of our employees, they work in the German-speaking area. So Germany, Austria, and Swiss area. And our international employees, they work in worldwide Gerstel offices. In Germany, we are always around the corner. We have different offices in Germany, and as you can see also in Switzerland and Austria, where we have sales and services very near, so always around the corner. Is that perfect, friends? Toujours à coin de l'autre? Is that around the corner? More or less, yeah. Worldwide, we are, as you can see, in a lot of countries. So the big red dots, they respond to the daughter and sister companies, and the little red dots, they belong on the distributors. Like Precision Electronic, hopefully will be our distributor very near, and then there will be a red dot on the Northern Africa territory as well. So you can see our strategy is to be everywhere, wherever that is possible. At the moment, we are very active in Latin America, where we deal with the products from our portfolio, like MOSH, MOAH, 3-MCPD, and PFAS. There's a lot of interest there. They're all catching up there as well. What does Gerstel do? Que fait Gerstel? There is a huge portfolio. Nos produits faits pour vous question analytique. Everybody has his questions, and we try to listen to the customers in order what they want. Mr. Gerstel started in 1967 with that, and his idea were spread it, and customers came to him and asked him, well, can you do this? Can you do this? Basically, what Gerstel is trying to do to be good in automated sample preparation. Automated sample preparation is so important because if you mismatch up with sample preparation, you get the wrong sample. And with having a wrong sample, well, you can have a that expensive detector, but you always have a wrong answer. And that's why we think that sample preparation, so préparer votre échantillon, is very important, very important. And to have that automated, it's the best there is, because nobody wants to work overnight. Nobody wants to work in the weekend. And if you have a robot, if you have a machine that do it, easy life. You can go home early. So there are things that we tried to invent and became successful with: thermal desorption. So using heat to do an extraction. Instead of using solvents, go for thermal heat and thermal desorb your samples. Doing things like pyrolysis on top, so having a higher temperature in order to paralyze the sample of your choice in order to get the right products. And later this afternoon you will hear a little bit about some examples how to work with pyrolysis and thermal desorption. Olfactometry means using the human nose. The human nose is the most sophisticated detector. Some people have a better detector than other people. A bigger nose has a smaller nose. But yeah, smelling is what we all do. So we smell nice smells, we smell not so nice smells. And that is also important in the industry, to have a good smelling product, or maybe having an off smell. So people have complaints and they call to the industry and say, hey, your product is not smelling nice. And then there is a quality assurance that have to do work on that. They have to analyze their products. And that's where the olfactometry comes in the picture. It is a parallel detection to your normal GC detection like FID or MS. And parallel, you can have an olfactometry detector port where you can smell, and parallel you can see the peak on your chromatogram and you define what you smell. Very important. A lot of people forget that, but in major companies like the Unilevers, the Procter & Gamble, they always have somebody that is responsible for olfactometry, because he is more or less interpreting what people smell. And again, we always, every day we smell and we taste, and we like what's smelling nice or tasting nice, and we do not like what is not smelling nice.
J'interviens de temps en temps, Samhouni. Donc juste Gerstel, il a développé essentiellement la partie préparation de l'échantillon. Donc ça, c'est le point fort. Et il a développé aussi donc, tous les outils ou l'instrument pour extraction avec la chaleur, donc pas de solvant. Et il a développé la partie olfactique, donc pour la senteur en fait, c'est en utilisant des instruments au lieu que c'est des personnes qui sentent l'odeur. Donc c'est un olfactomètre, donc juste un appareil qui va remplacer le nez humain.
It's very nice that you translate, because I can drink. Okay, so yeah, we are votre fournisseur de services professionnels. Now, when it comes to installation, to training, maintenance, introduction, repair, workshop, IQ, OQ. That is where we are your partner, but also our distributors are our partner. And that's why we want to see our distributors at least once a year in our facility in Germany, to having them trained, that they can do the training here, then they can do the installation here. They can do everything what we do in Germany, but then locally, to be at your service. So in these markets, the Gerstel technology, we feel home, we feel nice. And those are a lot. Flavor and fragrance, so again, what we smell and taste. Environmental, material emission, forensic, so means police, douane. Préparez votre échantillon, food and food safety, very important. Metabolomics, chemicals and polymers. So there are loads of markets, but you understand yourself which markets makes most money, and that is basically the flavor and fragrance again, because that's what we prefer, but also environmental. Every ministry is about talking about clean water, clean seas, having more tourists over. That's everywhere the same. And food safety. No? That is importing food, exporting food. So that will be also a chapter in this today presentations as well. So, food and drinks. Analyse de nourriture et boissons. So, very good, precise results to precise analysis. So, the automated techniques we offer there, you can see liquid extraction. So we offer there a quick mix, you will see later on, evaporation automated, so having everything in the autosampler. Sample preparation in general, things like centrifugation in the rail, in the robot. Everything we can have in the robot. I will tell something about the Gerstel twister, as it's scientifically it's called SBSE, so steerbar sorptive extraction. To exchange a liner of your GC injector automatically. Nobody likes to do that, but we can do that automatically. The robot can do this for you. Things like derivatization, SPE, online SPE, filtration, extraction, and large volume injection. So injecting larger volumes that you normally are used to do that. These are the things where we can offer automated techniques for. The solutions we offer for that is 3 MCPD. I will tell a little bit about it. MOSH MOAH, my colleague Udo will tell a little bit about. But we also have lots of solutions. We can host you here for a complete week and telling about acrylamide, ethylene oxide, mycotoxins, catchers, glyphosate, pesticides, antibiotics, vitamins. These are all things that the whole world is analyzing. They have to analyze by law. And this is what we offer, and where we can, with the help of Precision Electronique, can be your partner. Migration from packaging, when you have a package of orange juice, this is also what is on the inside, what is in contact with the juice. These are things that are all being analyzed, and that is where we can offer the automation. We offer application notes for that. You can download from our website. And there are also then things like posters we can share. So posters we present at exhibitions or at congresses. And these are just helping hands to give you an idea what you can do with our instruments as well. Here, for instance, one with LCMS. So LCMS, but we have, you saw before, with GCMS, GCMS. We have it all. You just visit our website, which is www.gerstel.com, and you can look yourself what could be interested, or otherwise contact the people at Precision Electronique. Saveur and parfum. This is not only about nice smelling, but also about off-smelling. Of course, we have customers like Chanel or Dior or Robertet in France. But also the saveur comes with off-smells, like companies like, major companies like Coca-Cola, Pepsi-Cola. They have maybe complaints, and how to deal with the complaints, how to analyze them to find out what the problem is. Because you can understand when there's a problem with such a major product like cola, it in fact causes maybe millions of dollars of complaints and money. Yeah. So what we offer there, the automated techniques, thermal desorption, so using the heat to do an extraction, dynamic headspace, so everybody knows static headspace, but dynamic headspace, you can sample more headspace sample. We have instruments called mixture maker to automatically prepare your own mixtures. Liquid handling, olfactometry mentioned before, the twister mentioned before, and yeah, doing of course also the standard things like headspace or liquid injection, automated SPME, thin film SPME as well. We can show you that later on. The solutions we offer for that is then an analyzer we called flavor analyzer. So it can analyze your the flavor you analyze. It is on a chapter called sensory data analysis. A mixture maker for preparing according a recipe, your own mixture. The flavors in beverages, remember the Pepsi Cola, the Coca-Cola, you have more than one taste. What is the taste? Or maybe a tomato ketchup where there never has been a tomato in it, but it is a technical flavor. These are things that are being analyzed with our instruments, of flavors where there are problems then with quality assurance. Material emissions, so what comes out of the material? For instance, in the car, in the automotive industry, when you buy a new car, you open the door, you think, that smells nice, that's new, that's my car. But that new smell is not very healthy, turned out to be. And now, of course, then the car producer, they have suppliers that supply the seat, that supply the dashboard, that supply the carpets. And now every supplier, they have to testify. They have to present a paper where there are no dangerous fumes or products are outgassing from the chair, from the dashboard, from the steering wheel. Because otherwise the complaint comes to the car producers, but the car producer says, oh, it's not my fault, it's the supplier that supplied the chair. And that is a big industry because every car manufacturer, they are doing that, they have to do that. It's also a legal aspect. Maybe you want to translate?
Donc, Gerstel intervient donc dans plusieurs domaines. Donc, le premier domaine, c'était l'alimentation et les produits alimentaires d'une façon générale. Donc là, on va insister aujourd'hui sur ces produits-là, tels que le 3 MCPD, le MOSH, le MOAH, et autres analyses, mais aussi il intervient dans tout ce qui est parfum, dans tout ce qui est odeur d'une façon générale et dans tout ce qui est émission de matériaux comme il vient d'expliquer, par exemple l'odeur qu'on sent dans une voiture, choses comme ça, tout ça c'est analysé pour éviter que cette odeur ou ces produits nuisent à la santé. Donc, Gerstel, c'est toujours la partie préparation, la partie extraction avant d'aller vers l'instrument.
Yeah, thank you. I needed a drink, that's why I asked to translate. No, but how they sample then? For instance, they have a little pump, and they, in a new car, they put the pump and they extract the air. And then they analyze the air with thermal desorption. That is how they can analyze the inside air, for instance, apart from the products the supplier produces. So there we have to obey to solutions. There are special methods where the people, they have to present the analyzing report, the VDA, reports, odor investigation, or even the foam inside a chair. Okay, environmental, and that's where we are everywhere, of course. The techniques we offer there is SPE, so solid phase extraction, automated. So everybody that once did SPE hates it, because you have to sit in front of a manifold and you have to wait till the last drop goes through the cartridge. But it is very nice if you can do that automated. And today we will tell you something about how to do that. The Gerstel twister, I will tell something about. You will hear something today about the TED, so thermal emission absorption, GCMS, pyrolysis, and doing that all online in combination with your GC or with your LC MSMS. And that's whatever, if it is water, air, or whatever. The solutions we offer, glyphosate, the PFAS microplastic, and the twister stair bar being used in this European Water Framework Directive that I will tell you a little bit about. Chemicals and polymers, this is of course a huge industry. So a huge industry where material testing and the determination of extractable compounds are using lots of techniques. And the automated techniques we offer there is thermodesorption, again this dynamic headspace, microchamber, pyrolysis, thermal extraction, liquid extraction, cleanup, and gas sampler, and extracting or analyzing the gas from a Tetler bag. These are all kind of techniques. This is used in the industry, and again to omit the fact that people have to work 24/7, that you can load an autosampler with samples that works overnight, works over the weekend, can be more precise, because an autosampler is more precise than a human being. The autosampler doesn't need to go to the doctor. The autosampler works on a Monday morning similar as a Friday afternoon. So that's why more people, they decide to go for an autosampler, as in the end it is more productive, more economical, because when the autosampler is taken over the work, the analyst can do something else. So the manager can get more work for the laboratory and can be more productive. The solutions we offer there have to do with the material emissions. Remember the foam for the chair from the car, but also material characterization. If furniture like from IKEA or something is being analyzed, it has to be safe, cannot smell funny. Maybe there are additives in there which are not very healthy or not supposed to be used. And, but also the analysis of process gas. So what comes out of a chimney from the industry cannot, of course, maybe go into the air, and that can be analyzed, maybe sampled in a Tetler bag or on a little tube, and then being analyzed. That is what we do there as well. Okay, medical and toxicology analysis. So tracking down the truth. So by police, by maybe douane. Automated techniques, again, we offer extraction, derivatization, where we can see it is more or less repeatable what you saw before. But also there, we have a lot of experience and a lot of customers. For instance, the technical police in France, they have a handful of labs where they have our instruments to do some toxicology instrumentation analysis. No? So things like THC, cannabinoids, opioids, cocaine, but also blood alcohol test. It is what is being analyzed everywhere in technical police labs or douane. Document forgery is the signature written by the same ink, by the same person, or the characterization of material. This is all what can be done with our instruments, on top of the adjuvant instruments that Precision Electronic presents, and that makes it a perfect combination, perfect deal. Pharma and metabolomics of the humans, of the plants. This is also, of course, a big issue where a lot of money is being spent. It is the future. Again, these are techniques, what we offer there, and that is the solutions where we offer there. So there's a lot of repeating things, but it shows that we also look into the future. What can we do there? How can we help there? How we can support? How can we automate all these analyzing things? Basically, it stands or falls with preparing your sample. Préparation des échantillons, increasing the efficiency, be more precise, and reducing maybe solvent consumption. The solvents that you used to maybe use is very expensive, but also expensive in getting rid after the analysis, and of course it's not very good for the environment or using these solvents. So where you can reduce that, minimize your method, that is very good. And yeah, we have automated techniques for that. Automated techniques, and again, these are the solutions that we offer that to clean, to evaporate your sample in the robot. So the robot does everything for you. Generating standards, so preparing your calibration standards automatically, that can be done by him or her, whatever you call this sampler. But he is doing the work for you, doing it very precise. We call it Laboratory 4.0. Yeah, every market has its things, and the question, of course, what is your market? No? Qui sont votre markets? And that is my first presentation on what is Gerstel doing, and where can we help you? What can we do with this? The advantages of automated sample prep. Well, you can read it. You can save time. You are in user-independent quality. Green analytical chemistry, no solvent or less solvent. Less stress work. Less risk to mix up your sample. Less risk of contamination. And less exposure to chemicals. That is also for all the people that work with the instruments. That is very, very important. And that is the logo there you see everywhere. Mm-hmm. You can have a translation or?
Merci, thank you. Comme vous l'avez vu, donc Gerstel, il intervient dans la partie pré-analytique. Donc, il offre des automates pour faire toutes les tâches qu'un analyste fait avant de passer à l'instrumentation. Bien sûr, ça offre beaucoup d'avantages. C'est la répétabilité, la reproductibilité, la disponibilité, puisqu'il peut travailler jour et nuit. Le gain de solvants, connaissant en Tunisie la réglementation sur les solvants, donc le fait d'automatiser ces gestes quotidiens de l'analyste vont vous faire gagner beaucoup de solvants et risques pour l'analyste lui-même, puisque ces instruments travaillent jour, nuit, et ils n'ont pas besoin de la présence de l'analyste. Voilà, juste. Merci.
Merci, Noureddin. Okay, so the second presentation I want to entertain you with is about solutions for 3-MCPD and glycidoester determination in fats and oils. So this one is complete in English, so sorry for that, but I will talk maybe a little bit slow. I hope that we understand. This presentation was done colleagues of mine, Oliver, Yasmin, and yeah.
Juste une précision, toutes ces présentations vous seront données à la fin de la journée, donc en format PDF. Sur une clé, donc vous aurez toutes ces présentations.
Yeah, we'll get everything on the stick, and that's maybe then easier. There we go. So these products are the products in edible oils, and edible oils is what we would eat and need in preparation our food. And that's where you see now on a lot of products, you see the content, the label on the bottle of oil. You see then the content of this 3-MCPD and the glycidol. And here is a slide where how it more or less is being produced when the tanker of this oil is coming into production site and being prepared. Yeah? Mm-hmm. Okay. And how these products like 3-MCPD and glycidol is being established. in the human body, these esters are converted to these 3-MCPD, 2-MCPD, and glycidol, and that is what need to be analyzed by these major labs that are more or less the companies that produce these edible oils. Yeah.
Je ne sais pas si c'est clair, mais ça c'est l'étape du raffinage. Raffinage des huiles, donc les étapes de raffinage, dégommage, blanching, déodorisation. Et donc ça génère, toutes ces étapes de raffinage, ça génère ces produits. Et ces produits, quand on les mange, donc ils vont se transformer en 3 MCPD, 2 MCPD ou glycidol. Donc ça c'est l'effet sur la santé. Donc maintenant il y a une norme, il y a des clients pour vous qui demandent ce type d'analyse pour s'assurer que les huiles ne contiennent pas ces produits.
Thank you. That was the word I was missing. Refinery, raffinage. But exactly, that's what they're doing. And then, these compounds in the human body, they are converted to these compounds there, the 3-MCPD, 2-MCPD, and glycidol, and these need to be analyzed. So the 3-MCPD, as you can see, is possibly carcinogenic to humans, and the 2-MCPD, there's only limited data yet, but some suggest a very high toxicity level, and the glycidol is probably carcinogenic to humans and genotoxic. So that's why they need to be analyzed. There is an urge for that, and the thing is, of course, how to do that. There are levels are known, maximum levels for the 3-MCPD. You can see in what kind of oils: palm oil, sunflower, rapeseed, olive oil, and but there are also other vegetable and animal oils and fats where you have then these levels. For instance, for baby food and its ingredients for the baby food. Similar for the glycidol, you see the levels, and basically it is a very prominent topic because we use edible oils more or less every day in what we eat or what we cook in the evening. We use edible oil, and that's why it's so important. But it's regulated, for God's sake, everywhere, all over the world.
Est-ce que ici dans la salle, donc les exportateurs, on vous demande ce type d'analyse ou pas? Ils sont demandés ou pas pour l'export? Non, ils ne sont pas demandés. Jusqu'à maintenant, non. They don't export. It's not outside, not requested this type of analysis. Mais bon, comme c'est une journée scientifique, c'est juste pour vous informer des produits dangereux, des contaminants éventuels qui risquent d'être exigés lorsque vous exportez donc les huiles ou les produits alimentaires. Puisque ces produits-là sont cancérigènes, sont considérés avec un risque élevé de risque de cancer et mutagène aussi. Bon, juste comme on a dit, c'est une journée scientifique pour information. Sachez que ces produits-là, un jour peut-être, ils vont être demandés.
Thank you. Maybe in the future, because we see in, for instance, in Western Europe, where then all the tanker ships, they come in the harbors from the Netherlands, Pays-Bas, and Belgique. That is where then the big tankers come, and where the companies are that are refine these oils and go to the big industries. And that is where the general sample preparation is needed. So a cleavage of the ester, what we saw in the former pictures, to transfer the esterification of the fatty acids. You have, of course, a lot of side effects that cause this. So they have to analyze, for instance, the fatty acids, the FAMEs. They have to do the extraction, and to do derivatization. And in the end, this needs to be done by GCMS or GCMSMS to determine these kind of products.
Donc, vous voyez, donc ceux qui ont déjà des instruments comme le GCMS ou GCMSMS, donc ils peuvent mettre au point cette technique pour les 3 MCPD. Donc il y a juste un protocole qui peut être automatisé par Gerstel, donc clivage, transformation, extraction des acides gras, donc méthylester, extraction encore et dérivatisation. Donc, mais l'essentiel pour vous, vous disposez, ceux qui disposent d'un GCMS ou GCMSMS, ils sont déjà prêts à faire ce type d'analyse. Donc c'est juste la partie préparation de l'échantillon.
And you will see in a moment that the sample preparation is very complex. There's a lot of manual handling for that. And that's where we offer then the automation for that. You will see in a measure. There are some methods, and we offer some application notes that you do not need to reinvent the wheel. No, you can, so you can follow such an application note. And there are different kind of methods defined by an ISO commission or with an American organization. Where these are written down. So the main one is a method called the ISO with the number, but it's in the words it's called the Zwageman-Overman method. That is the most recent method that is being used for analyzing the glycidol and the MCPD. As it mentioned, it is a fast transesterification. It was originally developed by Term, but now the method has been adapted and everybody can do that. But again, it uses a lot of instrumentation. But it was, the first method that was available for that. This was the second method. That's why it's called the letter B. It's called the Kuhlmann method. I think it was originally, this Mr. Kuhlmann was working for SGS, I think. And he defined this method or started this method. And, but at the moment there is no automation available for that because it takes a very long time. It takes an overnight derivatization of the assays. Now we have the C method, so the AOCS CD29C. It is called a differential method because you use the difference between 2 assays. And that is where we try to have our nose up front and what we offer our clients. And that is where we work with 2 assays, an assay A and an assay B, where we do then the saponification and the quenching in order to get then the glycidol and the 3-MCPD. And in the end, we can measure that. And the differentiation is to do that then with 2 assays. So you take more or less from the sample, you analyze it 2 times, slightly difficult, a different saponification and same quenching. Then we use here a bromide compound and we get there the compounds and now we can measure the difference between this. You want to explain a little bit?
Donc pour cette technique, il existe deux méthodes. Une méthode A, donc analyse de ces composés. Et il y a une autre méthode, donc méthode B par différence. Méthode C. Donc il y a la méthode B et après il y a la méthode C, c'est par différence. Donc ça, sont des protocoles qui sont fournis dans les notes d'application ou dans les normes. Donc, qu'il faut juste les faire. Bon, comme il a expliqué M. Peter, manuellement, c'est très, très difficile. Donc, pour cela, donc, Gerstel, il propose que ces étapes soient automatisées.
Because there are a lot of steps, as you can see already here, and that used to be done manually, and it can be automated then. And then the concentration of the glycine was calculated from the difference. That's why it's called a differential method. You see, this is where this is basically the method. And there are loads of steps. But with the, in the different colors, you can see where the autosampler takes over. And that is what the people would like to do and like to see having this done automated. And these are the Gerstel instruments in there that takes over the work. So the MVAP that you can see here on the left side, the MVAP is an evaporation module where you can have 6 samples in there, and it is helping with the pump. The pump is helping to create the vacuum in order to do your evaporation of your sample. It is being heated in there, so the MVAP is being heated, and the solvent is being evaporated with the help of the pump you see there. On the right side you see the quick mix. So the quick mix is our own vortex-like shaking. Up till 4, or it depends what kind of vials you have, and it shakes then, vortex-like, and it is both are in the rail. You can see the top; they are hanging in the rail. This one as well. So that means you do not need to go with your sample to a separate vortex shaker or to a rotavapor is not needed. Everything is in the rail. And again, that is what the people like. They like to have everything automated. Here you can see how such a setup looks in the lab. Again, here you can see there is the MVAP, and right from it is the vortex shaker. And that is the quick mix that it uses everything automatically. So everything is being automated in here, installed on top of the GCMS. On the right side, you have a different picture for a more or less similar setup. On top, you see the same as a standalone. So it can do the analysis standalone, and then the operator at the end takes the sample out and moves it manually to the GC or GCMS spec. So it can be online or offline. So our instruments are being controlled by a software which is called Maestro software. And this Maestro software has the advantage that it can be embedded into the Agilent software. And that is why the best solution is the Gerstel Agilent combination, because you only have one software. You have the Agilent control in the Agilent software, and the Maestro Gerstel software is embedded into the Agilent software. So you only have one software to take care of. One part of this Maestro software is called the Maestro Scheduler. It shows your throughput, and it shows where the sampler is busy with. So all these colors, they stand for a different sample part of the sample preparation. And in the end, it does then the analysis. And you can see when it's being analyzed, it already starts with the second sample, so you don't lose time. It is very nice, and you can see that here. So that means if you put all your samples in the autosampler and you go away and you come back and you look at the scheduler, you can see at the timeline, because there is a timeline in there, you can see what the instrument is busy with. If the autosampler is working with the first sample, or are they preparing the second sample, or maybe analyzing the first sample and doing already the second and the third sample. So that's a very nice issue, the Maestro Scheduler.
Donc les solutions de Gerstel, de préparation, donc bien sûr c'est cet automate que vous avez vu qui s'intègre facilement donc, aux instruments Agilent. Donc ils font toutes les étapes de préparation. Donc ils font l'extraction, ils font l'évaporation au lieu de, donc ça remplace l'évaporateur rotatif, ça remplace la concentration Ça remplace donc la dérivatisation, etc. Donc en plus, quand on met les échantillons, au fur et à mesure, donc il commence par le premier échantillon, une fois l'extraction est terminée, il va l'injecter dans les instruments pendant qu'il commence le suivant. Donc il y a une parfaite synchronisation, c'est-à-dire il prépare et il injecte en même temps, donc au fur et à mesure. Donc on a juste à faire la méthode d'extraction et la méthode d'analyse par GC-MSMS, et le robot, l'instrument, communique, synchronise leur travail pendant que le robot prépare l'échantillon, le MS donc fait l'analyse, et pendant que le MS fait l'analyse, le robot il prépare l'échantillon, etc. Donc c'est en parfaite synchronisation.
So we call it an overlapping. I mean, it's not waiting till the first assay is being analyzed. It already starts with the second assay or the second sample. Here then you see a picture, the chromatogram of the peaks. Or maybe not so interesting because these pictures are always promising. But anyway, that is where the calculation is being done. Now, in fact, there's no calibration needed because the quantification is being done different. And, well, of course, you need then the transformation factor. But, yeah, that is how such a picture looks like. Here the results that you can see with 6 analyses being done. There is, of course, a limit of quantification, but it depends on the matrix and your MS. But yeah, you see for a single quadrupole, in best case is 0.1 milligram per kilo. And yeah, that is for the triple quad, you can see 0.01 ppb per kilo, but that is, for instance, then for palm oil. That is the other method. I will maybe just rush through it because it's maybe not so important for you, but you can see what can be done with this. Of course, you have the similar saponification and quenching and derivatization in order to get the conversion from 3-MCPD to glycidol. And this is done via an internal standard. There's a lot of sample preparation steps here as well. And that is where we also have the autosampler ready to do that. That is where we work, for instance, with a cool tray, as you can see over here. So a cool tray that can go down to 10 degrees below room temperature. We have a heated agitator. And again, on the right side, you have the quick mix again, our own vortex-like shaking. Here you got an impression how an instrument looks like. Again here with the Agilent GC MSMS. The calculation is that you only need one assay, but it has to be then, of course, very precise, and you have to consider the recovery factors of both the transferation of the 3 and 2-MCPD and the glycidol. This is a typical chromatogram of such a method. And here what is being done to have everything clean is then that you do a so-called back flush of your compounds in order that it stays clean and ready for the next sample. Validation data, well, you will have it on your stick. You can read it at home. Some pictures of the peaks near the limit of quantification, so very low. But you see you have a very nice peak shape, very easy to calculate for the instrument. So the summary for that, there are different methods. And normally in the industry, everybody has said that they have to work according a certain solution. If it's the A, the B, or the C method, or the Zwagemann-Overman method. And that is basically the important message. And if you tell then us, for instance, that well, we have to work according the C method, then we can offer so a different setup rather than when you work for the Zwagemann-Overman method, but we can do everything, well, not everything, but the different methods that are being requested in the analysis of edible oil. There are application notes and experience at our Gerstel company, our brothers in Singapore, in the US and Germany as well. For the B method, there's no experience because of the fact it has to stay overnight in a cool tray. And I think that's it for me for now. Yes? So thank you very much for your attention. Sorry for not speaking French too much, but the next presentation will be more French. My next French presentation, but I think we first have a little pause, no? Yeah, okay. Any questions? Nearly forgot. But you can always pose Noordine a question, he can talk to me. Or if we drink a coffee together, you can always ask me.
Pour l'huile d'olive, donc les limites de détection, on peut atteindre donc les 5 ppb. Donc combiné avec un triple quad, avec un GC triple quad et l'automatisation donc de l'extraction. On peut atteindre les 5 ppb. I don't know the limit for the European.
Yeah, it depends on it depends also which method is being used.
There is a standard.
Yeah, on what oil? It depends. Different oils, different detection limit or limit of quantification are needed. But that is, if people want to know, they can contact us and we can tell. Yeah.
Donc, s'il y a des personnes qui sont intéressées par cette analyse donc de 3 MCPD, on peut leur fournir plus d'informations sur la réglementation, les limites demandées, etc. Je crois, Walid, Tchawash Walid, vous avez une... Oui, Walid.
سي نور الدين، حبينا نشوفوا اسك الميثود هذه تصير كوبلاج مع جي سي ام اس اللي عندنا ولا لا؟
والال سي نلقيهم كل مع بعضهم. فهمتي؟
سي بوسيبل. سي بوسيبل. Juste le robot. Mais c'est indépendant des autres analyses. Les autres analyses, maintenant, juste une autre méthode. La même colonne. Très bien. Juste une autre méthode. Très bien. Merci.
Bonjour tout le monde. Bon, je veux savoir les 3 MCPD, est-ce que c'est un contaminant réellement ou là, il se transforme, un composé qui se transforme durant l'étape, une étape de raffinage, une réaction, ouais. Ou est-ce qu'il y a une exigence juste pour les huiles raffinées ou là, pour tous les types d'huiles, vierges et raffinées?
précurseurs existent naturellement, mais c'est le process de raffinage qui fait apparaître ces produits. Voilà, c'est au cours. C'est pas un contaminant naturel, on va dire. C'est suite au process de raffinage. Et bien sûr, si l'huile d'olive elle est contaminée ou elle est mélangée avec des huiles de raffinage, donc on va retrouver ces produits. Donc ils sont générés par le process de raffinage. Donc les huiles raffinées contiennent, malheureusement, donc ils ne sont pas contrôlés.
Et maintenant, pause.
Oui. Donc je vous invite à une pause café, juste pour couper, et on retourne. Allez, tfadlou. Oui, vous pouvez ramener vos cafés avec vous, مش مشكلة احنا هنا. هاي هزوا القهوة نتاعكم مش مشكلة.
Oui, c'est pas grave.
Oui, c'est pas grave. ما تسخوش الطاولة وبرا. Ok. Allez. Bon, on reprend cette fois avec Monsieur Udo et on va parler de MOSH et MOAH. C'est les huiles contamination avec les huiles minérales saturées et aromatiques. C'est ça la différence. Le mot A, les deux lettres, c'est mineral oil donc huile minérale, S pour dire saturé ou A pour dire aromatique, et le H, c'est les hydrocarbures. Voilà, contamination avec les huiles minérales, saturées et aromatiques. Donc, on va lui demander de parler un anglais simple. Hein? Voilà. J'interviendrai éventuellement si nécessaire. Merci.
Okay, my name is Udo Bonham. So I'm the second one of the speakers today. I'm doing this with Gerstel here for 29 years already, and our topic will be MOSH and more for today. A question or analysis showing up and requested for more than 10 years now. We're talking here about a prefixed solution. So Gerstel is usually doing flexible sample preparation on your demand, but we have several setups we have done already prepared with all the parts you need. That's what Peter already talked about with the 3 MCPD. We have the same setup here for MOSH more. So the system here is usually in conjunction with the Agilent equipment, and it's completely prepared so that if you are interested or someone is going to buy this later on, maybe this is a complete solution, including everything you need to work. But first a word to all these compounds here we're talking about. So MOSH and more. One is the mineral saturated hydrocarbons. The other ones are the aromatics. And the question is, how do they just show up in your, or where do they show up? Because this is something which will enrich in your body. Yeah. So the entry pathway here is in every country the same. So we have the food production, machines, by harvesting machine oils, whatever is dripping or used to glue the machines. Transportation will have an effect on this one. The processing in companies or in production. And finally, this is one of the bigger parts, the packaging as well, because a lot of packaging material is coated with compounds, and unfortunately, it's MOSH and more compounds. So that's a public concern here. That's what showed up, I think, around about 10 years ago, a little bit more. The first requests have been done. It was a lot of manual work to extract these ones. So especially children food and the oils have been requested as the first analysis types. So a lot of companies now these days, they promote their products as much more free, but they need to prove. So our solution is, like most of the other competitors that we have, a combination of a LC and a GC detection. So this is not a secret. All of the solutions you will get on the market are usually based on this setup. So the principle here is that we extract, or we just separate the fractions of MOSH and more in a normal phase LC chromatography, just using a simple detector, and then we transfer everything into the GC. Both fractions will be separated, and both fractions will directly transfer into the GC, parked for a moment until the LC run is done, and then the GC run will start.
Donc, j'interviens un tout petit peu. Donc, l'origine, vous avez vu que l'origine de ces huiles minérales, tout au long du processus, depuis le début jusqu'à pratiquement l'emballage des produits alimentaires. Et notamment, donc, on est aujourd'hui concerné par l'huile d'olive. Donc, l'instrument, en fait, l'instrumentation, elle est basée sur un HPLC et un GC-FID. Donc, l'HPLC, il va permettre la séparation, donc une première séparation par HPLC en phase normale. Et après, donc, les fractions séparées par HPLC, ils vont être analysées en deux voies. Une voie pour les MOSH et une voie pour les MOAH. Donc c'est une combinaison entre HPLC et GC, FID.
So the fractions of the LC is usually a larger volume, so up to, and here it's 450 microliters, which will be directly interjected into the GC. This is the trick. Yeah? You need to get rid, for the GC, you need to get rid of the solvent, because this will just disturb your complete chromatography. We just separate the fractions in, or not separating it in fractions. So we have two channels in the GC where we do the GC run. What you would expect would be a chromatogram with single peaks, but for much more, that's not. So we will see later on how this looks like and how it has to be integrated. So important here is that you do one LC run and the GC run is one, so you have the MOSH and more results in one GC run. So it's time saving. That's the principle on how the setup is done here. So the LC column, we have two fractions eluting. By switching a valve, we can direct them to a column where we just store them for a moment until the MOSH fraction, the more fraction is eluted, and then both fractions will be directly injected into GC. And what you already see, the GC signals here are more or less just humps. That's a mineral oil hump, what you see.
Donc l'HPLC, comme c'est représenté, elle va séparer donc, les deux fractions MOSH et MOAH. Et la fraction MOSH, elle est envoyée sur une voie du chromato en phase gazeuse. Et la fraction donc, MOAH aussi, elle va être injectée sur une autre voie. Donc il y a un HPLC, une première séparation. Après, chaque fraction de l'HPLC, elle est injectée dans une voie du GC.
Okay, so when we inject this into the GC, the LC fractions, they will be placed on an uncoated pre-column, just to make sure that we can evaporate the hexane phase first. Or in case of the MOAH fraction, it's a mixture of hexane and dichloromethane. After this is done, the evaporation is done, we have a system which will just then close the evaporation valve, and then both fractions are transferred to the regular GC columns.
Donc, la difficulté ici, c'est que vous savez tous, donc, à l'issue de la séparation par HPLC, généralement on a un volume important. Et ceux qui travaillent avec les GC, vous savez que les GC, on injecte quelques microlitres. Donc là, il y a une incompatibilité a priori que Gerstel il a trouvé donc, la technique ou le moyen pour passer donc, l'échantillon de la phase d'un large volume donc à la sortie des colonnes HPLC pour réduire ou concentrer ou évaporer donc, la partie, enfin la phase mobile pour concentrer l'effluent et le faire passer par le GC, dans le GC. Donc ça c'est important, ce passage, ce couplage entre un HPLC et un GC. Voilà. L'autre elle va fonctionner avec des millilitres alors que la chromatographie en phase gazeuse c'est des microlitres.
Yeah. This is the typical gradient we use on the normal phase HPLC. So we start with 100% hexane. This will just run the MOSH here. And as soon as the MOSH is eluted, then we increase the gradient to 35% of dichloromethane to elute the aromatics. And after this is done, we just increase the dichloromethane content to 100% and backflush the column to make sure it's clean again. And this is done while the GC is running, so that it's not added to the usual runtime. We have an example of the elution here from MOSH and more. Some compounds are already mentioned here, so there are some compounds we use as starters or end markers, and in the end we use some of these compounds to see if the chromatography is done well and if the transfer from the LC to the GC is done correctly. So there's a ratio between different peaks which has to be fulfilled, and this will be tested in our company before we ship the system, and it will be tested on your site if the instrument is set up, so that we are sure the system is really running. So these are the compounds we're using here. So just an example for MOSH, we have the C11 is used as evaporation control. So if this is missing, then we know that there's something wrong with the evaporation. Yeah? We are evaporating too fast or too high temperature. Nevertheless, all of these compounds and everything is shipped with the system. So this is what we do. So, but it will be done in a familiarization and a training later on, that people just know what they are these compounds are used for. And yeah, you're trained to see or to determine problems if there are some. The UV detector is just a monitor detector. We are not doing any chromatography with the LC, not really. We just see that the MOSH and the MOAH fraction starting the gradient here will increase the signal of the UV detector. That's where we know that the MOSH fraction, the MOAH fraction starts, and the parallel, the PR, what you see there will be the end of the MOAH fraction. So that's when we know at which times we can switch the valves. So, and it's for you as well a visual thing that you see if the retention times in this monitor detector are still okay. If there would be a retention time shift, you know already there's something wrong with the column, maybe you need to exchange the column.
Oui, la difficulté pour ce couplage entre un HPLC et un GC, c'est de bien choisir le moment d'envoyer chaque fraction dans le GC. Donc là, c'est très très important. Donc pour ça, il y a des standards qui sont utilisés pour optimiser ou pour définir le temps de switch pour envoyer, quand est-ce qu'on envoie la fraction MOSH et quand est-ce qu'on envoie la fraction MOAH. Donc là, il y a des standards qui permettent donc de définir ce temps. Et donc normalement, Gerstel, il fournit une solution. Hein, donc avec tous ces standards et en plus de la méthode. Donc il faut toujours bien vérifier parce que si on ouvre la vanne plus tôt ou plus tard, donc on peut ne pas analyser la fraction désirée.
Okay, what you see from the gradient here is the backflash of the column is included as well. You will see that later on the DCM is reduced to 0 n-hexane and it's going back to the baseline. So what we talked about, that's the 450 microliter injection into a GC, which if you do GC, you know this is really a challenge. Yeah, you need to get rid of the solvent. And especially if you're injecting 450 microliters, the solvent needs to be very, very clean because in any other case, you're doing an enrichment of the dirt inside. So I think it's a small animation here. So that's what we do. We place the fraction on the pre-column and then start the evaporation of the solvent. The solvent will move down. The compounds will stay at the pre-column and then the solvent is evaporated through a valve into your lab air, or I hope in the fume hood, something like this.
Donc là, c'est l'interface, donc EVE, le principe, c'est comme un injecteur, donc style injecteur, splitless, une chose comme ça. C'est-à-dire là, on introduit l'effluent qui sort de l'HPLC, donc vous voyez, c'est un gros volume. Donc, et cette partie-là, c'est considéré comme une colonne, mais sans phase stationnaire. C'est juste une colonne qui va être chauffée et le solvant d'élution de l'HPLC, il va être évaporé, éliminé et après les composés d'intérêt, donc les MOSH et les MOAH, vont être piégés dans un premier temps dans cette partie-là et après on va les volatiliser en augmentant la température et à ce moment-là, cette partie-là, elle va être fermée et les composés ils vont être envoyés dans la colonne analytique.
Yeah, so I think you already described what's going on. We close the valve here and then we heat up the oven and the analytes will be transferred. So what you get as a result, a typical result, and it's on both channels the same result with a slightly delay, is just the part here which is interesting is just the small hump here. That's what you see.
Donc là, vous allez être un peu déconnecté ou déphasé. D'habitude, on s'intéresse, donc chromatographie, on s'intéresse aux pics. Pour le MOSH et le MOAH, ce n'est pas les pics. Ça ne donne pas des pics MOSH-MOAH. MOSH-MOAH, ça donne cette patate, on va dire. C'est cette partie-là qui nous intéresse, pas les pics. Donc il va y avoir un challenge après avec le logiciel. Il faut enlever les pics. Enfin, il faut...
Yeah, okay, that's the theory. So that would be a standard. That looks like a standard here. A real sample looks different. A real sample usually has a lot of peaks on top of this hump, large peaks, depending on the matrix, the source of the MOSH and MOAH. This can be very, very difficult, and you have to integrate this hump to make sure that you're not integrating the peaks. So this means some of the samples we're analyzing need sample preparation. And that's why we talk about this topic here. Usually we have this classified a little bit so that you have an impression what is easy and what is a hard metrics to do. So for especially what is requested very often at Gerstel is spices. So spices is really a hard metrics to compare because there are a lot of disturbing compounds on top of this one. Dry foods, mineral oil, white oil, this is more or less easy. That doesn't not always need a cleanup. For the packaging and up to the fat and oils, usually there's epoxidation needed, and sometimes to lower the detection limits, we will need a saponification as well. That's a little bit depending on the detection limit we want to achieve.
L'image de tout à l'heure, il s'agit d'un standard, donc c'était simple, c'est clair, mais en réalité, c'est plus complexe que ça, puisqu'il y a dépend des matrices. Il y a des matrices faciles, des matrices donc moyens, intermédiaires et des matrices qui sont très dures. Donc si on se situe en ce qui nous concerne aujourd'hui, par exemple l'huile d'olive, il est considéré comme une matrice moyenne. Et de point de vue préparation, la difficulté, il faut procéder à ces différentes étapes pour la préparation de l'échantillon. Époxydation, saponification et nettoyage avec l'aluminium oxyde d'aluminium.
So depending on your compounds or your metrics you are looking for, yeah, this might be already an idea that there is some sample preparation or some cleanup needed. Yeah, so detection limits here. The palm oil and sunflower and coconut oil, whatever, they need to be diluted. That's the first step. Yeah? The epoxidation for these oils is always mandatory. If you're not doing an epoxidation, then the more fraction will be completely, I wouldn't say completely wrong, but the chance is there that you have a too high result. Alox cleanup is used for the MOSH fraction to remove single alkane peaks, which in the high boiling range could be disturbing. And the limits of quantitation required is usually 2 ppm. Now these days, people always need to go lower to 0.5 ppm already, and then the cleanup is really mandatory. Whatever you do, it's mandatory to clean up these samples to reach these detection limits.
Donc, sans étape de nettoyage, on arrive, bon, il y a les étapes, hein, saponification, époxydation, alox ou oxyde d'aluminium. Donc, il y a des étapes qui sont optionnelles, des étapes qui sont obligatoires, des étapes donc, qui sont voilà, parfois optionnelles, parfois... Ça, si on fait donc cette injection, généralement, on atteint une limite de quantification de 2 ppm. Mais si on veut aller plus loin, si on veut descendre en limite de quantification, il faut procéder à une étape de nettoyage, clean-up.
So usually the sample preparation can be done manually. There are several methods available to do this, but yeah, it's again manual work, steps you don't want to do or they take very long. So we try to optimize this with the automated sample preparation. So we started with the allox cleanup, then epoxidation, and the last sample preparation we added here, or the last cleanup I must say here, is the saponification. So for the saponification, we start the other way around, like we developed it. The last one was the saponification done here. We can handle 6 samples at a time, and there is, at the moment, there's a discussion going on of this saponification will be extended to a solid phase extraction. So that's talk in the European Commission, that they are, yeah, in the German Commission as well, talking about this add-on that will be required to clean up the samples in an additional step to get lower detection limits again. The epoxidation is needed for the MOAH fraction, I already told you. So the epoxidation is based on the performic acid. There are several other methods available. We prefer the performic acid, MCPD. I must admit I can't tell you the shortcut at the moment, but it's possible as well. So if a customer has already a method using MCPD, then we can translate this one easily as well. It's the same setup. It's just a different standards we are using, reagents using, but in principle the system is the same. It's just a different method. That's possible.
Donc,
yeah, for the MOSH cleanup, that's the allox cleanup for the MOSH fraction is done online. It's done before the MOSH fraction will be injected into the GC. So we run the parked fraction through an allox column and then into the GC. That's just to remove the alkanes which from natural origin, and they just need to be removed from this hump so that there's no interference with the system or with the results.
Donc pour l'étape de saponification, donc ceux qui analysent les stérols et autres, donc ils le font. Ils le font. Donc pour améliorer surtout les normes en Allemagne, donc nécessite une limite de détection encore plus faible, et pour atteindre ce niveau donc de limite, donc maintenant il rajoute un SPE, donc c'est une extraction en phase solide. Ça c'est nécessaire si on veut encore descendre en limite de détection. Donc c'est vu la norme, I think la norme in Germany is very low. And, ouais, voilà, la norme allemande et européenne exige de descendre encore plus bas en limite de détection. C'est pour ça cette étape de SPE, elle est pratiquement maintenant, elle est devenue indispensable. Voilà, donc les autres étapes, époxydation, c'est pour la fraction MOAH, et la LOX, le nettoyage de cette, avec l'oxyde d'aluminium, c'est permet donc une bonne détection des MOSH.
Okay. Yeah, let's go through the saponification. That's a step. That's a sample preparation here. You get all these slides and can read this later on. The setup here, that's the manual method that is used at the moment, and we are just translating this into an automatic sample preparation. We're using a standalone version of the sampler, so it's not hooked up to the LC and GC anymore, because we have much higher sample throughput with the system. And the other reason is, depending on the metrics, we have seen that if you do the saponification, the phases, the water and oil phase, will just not separate all the time. So we've seen samples where this is critical, and you've seen the process here. If you inject one of these samples into the GC, this will require a cleaning of GC or exchanging the columns at least, yeah? Cleaning everything. So this is a lot of work. So that's why we decided from the company we're going for 2 samplers. But if you have simple samples, which you know separation is done correctly, this can even be set up on a GCLC or LCGC system. That's possible with the fact that you have less sample throughput but directly online. So the idea here is that if we do it offline, the user or the lab technician in the morning or whenever he's going to has a quick check of the samples if they are done correctly, if the separation is correctly. Yeah? If this is not, then they can just remove the samples from the list without damaging the system. But it's possible as an online system as well. That's not a problem.
Pour la partie saponification, Gerstel il a choisi de mettre un module séparé. Vous savez tous, hein, la saponification, il faut faire une extraction liquide-liquide pour séparer la phase aqueuse de la phase organique. Et cette phase donc, dépend d'une extraction à une autre, donc on peut ne pas avoir toujours le même niveau. Donc c'est pour ça que c'est difficile d'automatiser. Et pour avoir des résultats, de bons résultats, donc ils ont préféré d'offrir un module qui fait la saponification. Donc une fois on a fait la saponification, on prend la phase organique et on peut donc faire le traitement en automatisme intégré avec l'instrumentation. Donc juste cette difficulté parce que lors de l'extraction, de la séparation de la phase, elle peut ne pas toujours être au même niveau. Donc on risque, si on veut prélever, on risque au lieu de prélever la phase organique, on risque de prélever aussi la phase aqueuse. Et donc ce qui va gêner après, donc, on ne peut pas injecter la phase aqueuse dans les GC. Donc la solution de Gerstel, c'est un deuxième module pour faire cette partie de saponification, que vous faites quotidiennement hein, chez vous, dans les laboratoires. Vous faites la saponification, donc avec du carouage, etc. Et après, vous faites une extraction liquide-liquide, vous récupérez la phase organique. C'est à peu près la même chose, mais ici, un module pour faire toutes ces extractions automatisées.
Yeah, the advantage of the system, there's a second thing to mention. The standalone sampler here is just used or just required if we do the saponification. The sampler setup itself can be used for several sample preparations as well, not only for the saponification of MOSH. So if there's another need for sample preparation, there are a lot of options already installed at this sampler, then that can be used for anything else in the lab.
D'accord. Donc ce module-là, il peut être donc dans votre laboratoire, il peut être utilisé pour les autres applications, par exemple pour les stérols ou autres. Donc pas uniquement pour les MOSH et les MOAH. Donc un seul, il peut être utilisé pour d'autres applications. Ils peuvent mettre au point le protocole d'extraction, de préparation d'échantillons pour autres applications. Donc ça facilite le travail dans un laboratoire.
So okay, so this is for example a setup here from a system which is usually used for the saponification, for the epoxidation as well. The allox cleanup is still done at the LCGC system with a smaller sampler. There's just a column which is switched with a valve. Yeah. So just a quick go through. This is the mixing module. A centrifuge is mounted here. The evaporation module Peter already showed you. We have a system here which can decap the vial so that you have the samples without penetrating the septa. From the septa you will see compounds like siloxanes getting into the samples. The siloxanes will be part of the MOSH hump, I guess, again, so it's disturbing again. So that's why we suggest to use a decapper here so that we have no interference from these compounds to the results later. Yeah, the SPE, it's at the moment optional. So this is not included as long as we don't know if it's really required and as long as the norm is not changed. It's already shown here because for later setups, we need a larger sampler to make sure that it fits. If you buy a short sampler, there is no way to extend it, except buying a new sampler. That's fine for us, but not for you. Yeah, the tools which are needed to handle the different cycles here, and the system is equipped with two heads. One of the heads here is can change the tools on demand. So depending on the tools which are needed, large volume, lower volume, or maybe a system which just handles the internal standards, just to make sure it stays clean, that can be changed or will be changed by the system automatically. The method setup is completely shipped with the system. While setting up the system, everything is set up here, and finally it's just the first runs that you will be guided here, and that's it. Yeah, an agitator here is for shaking heating. So here is already a lot of the Gerstle stuff involved, and this is really a sampler which can be used for nearly any type of sample preparation. So there's not much more you can install here. Solvent reservoirs, so for the solvents that you will need to prepare it. But it's just, okay. No, wait.
Donc ici, pratiquement, vous trouvez, vous avez tout votre laboratoire. La centrifugeuse, l'agitateur, le mixing, le décapage, le solvant, l'évaporateur, l'injection, le SPE qui est en développement actuellement. Donc vous mettez votre échantillon d'un côté et lui, il va faire toutes les étapes que vous faites dans votre grand laboratoire. Donc en fait, tout ça, c'est un petit laboratoire mini et il fait tout. Voilà. Et à la fin, votre échantillon, c'est ici. À la fin, c'est ça qui va être introduit dans le GC éventuellement ou dans le vial pour l'utiliser ultérieurement.
Yeah, so this is the 2-meter version of the sampler. It's not the largest one, but it's the most common one for the sample preparations here. So the MOSH cleanup, MOSH cleanup, it's an aluminum oxide column used to remove the alkanes here. This is done at the LCGC system with a small sampler. If you have compounds only needing the LOX cleanup, then it's just the LCGC system with a sampler on top. So the problem here was more or less to find an LOX column which can be used, because usually in the method it's written that you need freshly prepared aluminum oxide, heated. But we found a supplier here who did it for us, and these columns are really working very well. The improvement here for the MOSH will be just down to 0.5 milligrams per kilogram. So this would be the usual manual setup here. You have a manual column packed with aluminum oxide and silica gel. Then you have a gravity flow using 80 milliliters of hexane. The automated one is a little bit different. We know that the column lasts around about 500 runs. That's for sure is depending on the metrics and what you load here. In the end, we need 10 times less hexane, and it's high-grade purity hexane, which is very, very expensive at the moment. And in some countries, this is even not available. So we had some problems setting up the systems because we needed to get the hexane. This will be part of, it's a local dealer which is needed for the hexane, but it's available, so that is not really a problem.
L'avantage de cette technique automatisée, c'est qu'en manuel, vous voyez, donc les cartouches sont utilisées une seule fois, ils ne peuvent pas être réutilisés. C'est comme lorsque vous faites par exemple le cire ou des choses comme ça, à chaque fois vous changez de colonne. Et la consommation en hexane, elle est de 80 millilitres. L'automatisation, vous voyez, donc la colonne, elle peut servir jusqu'à 500 échantillons. Et en plus, vous voyez donc la consommation en hexane, elle est pratiquement 10 fois moindre. Donc avec les problèmes des solvants dans les laboratoires, donc tous vous êtes confrontés donc aux problèmes des solvants, à l'achat, à l'utilisation, à l'élimination. Donc cette technique offre donc un avantage important.
So some examples here. This is done LOX cleanup. That's the first sample without the LOX cleanup. You see this? You see here in this region, the alkane peaks showing up, yeah? And after the Alex cleanup, this is completely removed. So this is a customer sample, you see there, yeah? And you see here these peaks on top of it. So integration here will be a challenge, yeah, or more challenging than before. After cleaning it, yeah, you see the number of peaks, and the peaks on top here are really, nearly disappeared completely. So it's much easier to integrate here. And the integration is what's the main part for this analysis later on. Yeah, the epoxidation is used to remove unsaturated substances, polyenes from the origin. What we must admit here, and that's with every system in the world, as soon as you do the epoxidation, you will do epoxidation of your MOAH fraction as well. So you will have a loss of MOAHs. But this can be compensated by calculation. This is the important part. But this is the only way to get a real nice hump later on that can be integrated easily. And then the calculation about this loss is, an add-on.
Il faut tenir compte que cette étape de nettoyage par époxydation, puisqu'elle enlève tout ce qui est insaturé, donc bien sûr elle va influencer sur le résultat du MOAH, la partie aromatique de ces huiles minérales. Mais par calcul, on peut compenser cette perte. Donc il y a une perte, mais elle sera calculée et on compense cette perte.
So the compounds which epoxidated, they will be part of the backflush system in the LC, so that they will never show up in the GC. So for the epoxidation, there are different methods available. We already just told you at the beginning. So usually what we prefer is the epoxidation with performic acid, because this is user-friendly and easygoing. So the other ones you have to be a little bit more careful, and the chemicals they use are not, let's say, user-friendly, so they are harmful to you. So this is our recommendation. That's how our setups have been tested, and the results have been done with this setup.
Donc 3 différentes méthodes pour faire cette époxydation, et d'après M. Udo, ce qui est recommandé, c'est la dernière en utilisant de l'acide performique. C'est la plus simple et c'est celle qui donne des bons résultats.
So all this cleanup and sample preparation have been done just that we get an easy chromatogram to integrate. Oh, it's not a chromatogram at this time. That's the problem. So and that's where we start with a data evaluation. So you can imagine now if you have to integrate this hump and sit there and just select the integration line, removing the peaks on top of this is a little bit annoying. And the problem is if different people are doing this, you will get different results. I show you some examples at the end of the slideshow here. This is our most common, most impact on this MOSH system, because we have a very, very good data evaluation software. So it's usually a one-click data evaluation. You just have to check it visually and to check the markers if they are correct, and then you can be sure that the result is really, really good. We have an own company, or we have a company working with us, and they set up this integration here, and it took a long time for them to find out how it works best, but finally we have a really good software, and we just talk about this here. So these are the common chromatograms, or you see, you have seen this already. So and now what you do, you have this chromatogram, you have these peaks on top, you have to cut it away. If you do this manually, you do it from peak end to peak end. Yeah? Depending on the peaks on top of this hump, this will be take some time. We calculate around about 20 minutes for a chromatogram which will take. And what our software now does, it's running this in several cycles and just doing a smooth, nice integration of this hump. And in the Gaussian hump, they tell it's not really Gaussian, but very, very close to it. So it's a typical chromatogram. You see all the results. If you would have to run now this line here beneath these peaks, you have to go to every peak, do this. Even if you use the automatic integration supplied by the chromatographic system, this might not be correct, and you have to check this one. So with our software, the first thing our software will do, it will have a look on the on our standards. So and then you just check if the relation here is quite okay. That's the first impression. So you get a visual impression here: green, red, and then it's going to separate different ranges of alkanes, of MOSH and MOAH. So this is requested nowadays by the companies, and the next request, we're sure, will be the identification of the systems with a two-dimensional GC by GC, but this is not fact at the moment and will show up. But this software is already dividing this into the sections of different C ranges and calculating the single results. Yeah. And finally, what the software will do as well is it will print out a report with all these values. If you want, and that's part of the setup here, the company logo and everything can be included. It can be slightly modified, that's not a problem, so on your demand. This is the advantage here. So it's usually something which takes about a minute or two to check the results. Yeah, and if you are sure the results are good, or that's what you expect, then you can print the report directly for your system. So what I talked about was the different users, and I was not sure if this was working here. So this is a chromatogram we have done with 5 different users and with the software. So what you do, you're just looking to the hump, yeah, which you don't really see at this point. This is the first thing. So you see, oh, there's nothing wrong. There's something. Just the disturbing peaks are the problem. This is what you will do manually, and this is what the software will do. So we had 5 different operators at Gerstel. The experienced application chemists had to do this, so a little bit annoying work, but they needed to do. They did it, and the results, just come on. This time it works. Last time I didn't show the results of the users. And you see, the auto-integration from the software showed 9.1. Where's the last user? One user, number 4, was really close to it, and it's a reference standard, which we did here. Yeah? So it's a round-robin test we did with this sample. You will see one is 10.25, the other ones are 18 and 20, so they are quite off. So you won't pass the round-robin test with this one, for sure not. But the rest, 10 and 9 is really close together, they would made it. But it needs experienced people, and it takes time. That's the message. So you have to be really sure that you have the time to do this, and if you can save this time, that would be a real advantage here. And that's the advantage of the software. That's really the impact here.
Le grand avantage de la solution Gerstel, c'est le logiciel en fait, qui va avec, et surtout pour la partie intégration. Donc, comme ce tableau le montre, donc le faire manuellement, donc l'erreur elle est importante parce qu'il faut intégrer chaque pic individuellement et c'est pas évident. Donc le fait qu'ils ont développé un logiciel, un algorithme, donc pour faire cette intégration automatiquement. Et donc là, ça c'est ce qui les distingue par rapport à leurs concurrents. La solution est toujours identique, hein, quel que soit le fabricant, c'est toujours ils offrent la même chose, mais l'avantage de Gerstel, c'est le logiciel. Donc pour faire l'intégration automatique.
Yeah, you see the RSDs here from all of the samples is quite large at some points, but yeah, that's the way it is. Huh? That's manual integration. Okay, and as a short summary, yeah, that's something you can read later on how we do this and what. That's a repeated thing from my colleague here. Important is that we have an automated solution for this one. Depending on your sample, you can choose the sample cleanup, and at the end, the work, integration, and results are done by software. That's it.
Merci. Donc, pour résumer, la solution Gerstel, c'est offrir de la slide. Ah, ok. Donc, c'est un HPLC simple, phase normale, avec un détecteur UV. D'accord. Le détecteur UV sert à repérer donc les standards pour savoir à quel moment on doit switcher et envoyer les fractions au GC. Deuxième partie, un GC FID double voie, c'est-à-dire on a 2 détecteurs, 2 colonnes. Autre partie, c'est ce module qui fait l'interfaçage entre l'HPLC et le GC, et pour faire donc l'automatisation de, on a dit la saponification, il est préférable de la faire en dehors du système, mais les autres étapes de nettoyage, d'époxydation, ils peuvent être automatisés. Et tout ça est géré par un logiciel donc, de Gerstel qui pilote l'HPLC, le GC, les valves et en plus la partie intégration et impression de rapports. Voilà, donc tout ça, et bien sûr tout ce système, il est validé chez Gerstel avant qu'il soit envoyé donc, au client. Donc les appareils doivent être envoyés ou achetés directement de Gerstel. Ils font toute la partie optimisation et après, quand ils l'envoient chez les clients, ils vont refaire les tests pour vérifier qu'il n'y a rien qui a été changé. Et donc c'est une solution. Il s'agit d'une solution et pas d'un instrument. Une solution complète. Merci. Des questions à M. Udo? Pas de prix aujourd'hui. Hein. Donc, on ne répond pas à la question de presse. Not today.
Nope.
Pas aujourd'hui. Pas aujourd'hui.
Merci pour la présentation. Donc, si maintenant un laboratoire a décidé d'investir dans un tel équipement pour l'analyse des huiles, par exemple, et le lendemain veut faire une autre analyse, telle que les matrices chargées en eau ou les matrices chargées en sucre. Donc, les modifications sont-elles des modifications simples à faire ou on doit faire recours aux fabricants? Voilà.
One instrument for olive oil, for example.
Yeah.
And after that, they have other matrix, like water, like other things. Is it possible to develop the same instrument?
Yeah, so this is what I told you. So the instrument can be used for several setups. So we would suggest this one to be used for MOSH more. Yeah, but you can change the purpose of the instrument just by changing solvents or different buffers.
But we have epoxidation step, we have saponification step, the alloys, how to remove those steps. Is it easy to do for an operator in the lab, or we have to contact the manufacturer?
So no. So if we're talking about alloys, this is part of the small setup you've seen. This can be just chosen if you want to do it or not. Yeah, that's switching a valve. That's done by operator. Usually the Maestro software, and that's a little bit annoying here to show software on a presentation. This is really easy handling. Yeah, even changing some steps of sample preparation, how this will be done, it's easy going. We usually invite the customers to our location or to a reference customer just to see how easy this is done. So for my example here, we had the company Bayer 4 weeks ago. They brought some lab technicians into our lab and they should set up a sample preparation method we told them. Yeah, so they needed to have these add steps, move steps for the vials, whatever. And after half an hour, they said, that's easy going, there's no explanation needed. So that's not really a problem. So if you want to skip the saponification, then you just take the steps for the saponification out of this sample preparation. Yeah? Delete it, save it as logs only, and then you run this method. This is really one of the things I like, and the software is what our people sometimes tell very, very old, but it's very, very simple, and it can do everything you need to do. This is my favorite on this software. Yeah?
And is there other module to connect if we are dealing, for example, with high sugar matrix?
Which kind of matrix? Sorry?
High sugar matrix, like honey, for example. Or
that's now a good question. So now we need an application chemist. So, but that's something we can ask the application team. But I'm pretty sure that's possible. So, but that's something I cannot answer now. Okay, sorry for this.
Merci pour la présentation. Bon, aujourd'hui, la Commission européenne prévoit l'entrée en vigueur des limites maximales pour les MOAH dans l'huile d'olive à partir du 1er janvier 2026, je pense. À cette date, les produits devront respecter les seuils. Par exemple, les MOAH ne doivent pas dépasser les 2 ppm. Et si on voit la méthode, il existe actuellement une méthode officielle, elle est publiée en 2024. Dans la méthode officielle, il existe 2 techniques. La technique est LCGC en ligne. Il y a aussi une deuxième technique, la chromatographie bidimensionnelle, couplée à la spectrométrie de masse. Et je pense qu'avec un détecteur TOF. Est-ce qu'il y a une différence entre les 2 techniques? Est-ce qu'il y a une technique plus fiable? Surtout, il existe actuellement des experts chimistes d'ICOI en train de faire des investigations. Ils ont trouvé qu'il y a, même avec les techniques LCGC, il y a parfois des interférences avec les triglycérides. Ouais. Donc, ma question, surtout en Tunisie, il n'existe aucun laboratoire ou organisme qui est équipé avec cette technique. Qu'est-ce que vous choisir? Quelle est la technique la plus fiable, qui donne des résultats plus précis?
So for GC TOF, this is not available at the moment. So the data evaluation here is not set up.
International Council are studying 2 technology or 2 methods.
Yeah, so that's what I told you. That's what's showing up. That's a GC by GC, and with TOF. But it's not included here at the moment. And it's not at the moment.
C'est un investissement lourd. Donc il faut choisir la technique la plus performante. Peut-être un petit peu l'utiliser 2, 3, 5 ans. Peut-être elle devient après une technique obsolète.
The lowest injection limit, because the standard start with 2 ppm now.
Yeah.
Perhaps in the future they will ask for lowest.
Yeah. So that's what we have already.
And the cost is single GC, that big investment, and they want to know if this solution can
So
fulfill
So in principle, if we keep the sample preparation like the LC-GC combination, then the detector is just a matter of, whatever you can offer. The software, and integrating this is a complete different software for QTOF or benchtop QTOFs. This is really a fast scan with two-dimensional software. That would be a complete different software. It's not a request at the moment, but you're right, it can show up. But at the moment, this is what we are focused on is here, the sample preparation. So that's the first goal you need. You need to remove all these disturbing compounds from the sample. And that will be the same even if you do GC by GC with a QTOF or something like this. We lowered the detection limits to 0.5 milligrams per kilogram. If we have the request in the future to lower it, we will start over again and just have a look at this one as well. This is what we do. We monitor what's going on. And for MOSH More, we have a partner lab where the people are two guys. They're only doing MOSH More, nothing else. And they're using our automated solution as well now. Not for everything. For the spices we have seen here, this is a little bit difficult. But they are part of this commission. And that's why we know that the SPE cleanup, and that would be the next step, saponification and the SPE cleanup will lower the detection limits as well. But we are waiting until this is confirmed that we have to implement this one as well. We already planned it for the future here so that you have a future-proof system. This is for sure. If the detector changes, we will see. That's because this is a large investment later on. So the sampler here is sample preparation and a GC LC, simple LC and simple GC is not this much money, but a QTOF and especially with a modulator and fast electronics, which you need at this time, this will be a different investment. But our goal here is just to reduce the interference of the compounds, and if we can do this, that will be sufficient for you as well, I hope.
La focalisation actuelle est plutôt sur la partie préparation. Donc voilà, et c'est pour ça, tout à l'heure on a parlé de 2 ppm sans le SPE. Et vu que les normes européennes ils veulent descendre encore plus, ils sont en train d'introduire une étape, l'SPE, pour arriver à 0,5. C'est pratiquement 4 fois. Donc peut-être le jour que les normes changent, ils vont encore travailler sur la partie préparation. Bon, bien sûr, le QTOF, c'est une autre histoire. Déjà, l'instrument, il est plus fragile. La technique, donc QTOF, donc, le système utilise le vide. Et vous allez voir, à chaque fois qu'un système utilise un vide, il est plus fragile. Et ça nécessite plus de maintenance, plus un coût de fonctionnement, de maintenance. D'accord, on peut peut-être descendre dans les limites. Oui. Oui, donc avec ça, c'est un GC, FID, HPLC, donc il n'y a pas plus robuste que ça. Oui, pour le moment, avec ce système, on arrive à 0,5. Maintenant, il faut voir quelle est la norme. Pour le moment, il n'y a pas de norme. Il n'y a pas de norme fixe. C'est-à-dire, c'est les constructeurs ou ceux qui développent ces techniques, ils essayent donc de descendre. Mais ils jouent pour le moment sur la partie préparation.
Les MOSH et les mois vont entrer en vigueur le 1er janvier.
Le 1er janvier, donc pour information, M. Hazmi dit qu'officiellement, donc, le MOSH et le mois.
Je pose la question là.
Et ils ont dit que c'est en 2025. L'information, elle est 2025. Il n'y a pas de certitude, donc à chaque fois, vous savez, je crois que c'est la politique des étapes. Donc ils annoncent, on va faire ça, ça va être devenir, donc ça laisse le temps aux institutions, aux laboratoires de commencer à y penser, de budgétiser.
Les demander parfois par des clients.
Oui, le client. Oui. C'est une exigence.
Exigence client.
Oui, actuellement sont des exigences clients. Mais, oui, des pays. Mais ça va pas tarder, ça va pas tarder à devenir donc une norme ou normalisée, vu les problèmes que ça peut causer. Mais pour le moment, la plupart, il y a, je crois, un autre constructeur qui fait le cut-off. Mais le cut-off, déjà, le logiciel, le niveau d'utilisation, etc., ça demande, pour l'interprétation, pour ça, c'est pas aussi... ici, ça reste... Oui, oui, bien sûr. حتى هذا مش رخيص، حتى هذا مش رخيص. حتى هذا لا يستهان به. حتى البري هذا مش رخيص. Donc, just the question between these solutions and the cut-off, MS.
Okay, so if there are any questions?
D'autres questions?
Thank you for this presentation. If you want to prove if there is migration between the packaging and the product, should we analyze MOSH or MOAH or both of them?
So usually both are measured, so you can measure it in your packing material, and for sure you can measure this in your food, whatever it is. Yeah. So you can measure it in both type of matrices to see if it's moving into the. But usually, if the packaging is, that's the common thing what we've seen in the past year. So as soon as we have MOSH and more contamination from the packaging, then it's migrating into the other direction as well. So,
Okay.
so usually it's done both, and it's one run here, so it doesn't really matter. So you inject a sample and it will automatically do MOSH and more. Yeah. So it's a little bit depending on the packaging material and your supplier, what they will confirm what they use. Yeah. Usually the mineral fractions coming from any glue or from any surface where the packing material runs through. Yeah. So like plastic foils, usually they use two types. They're using vegetable oil to make it run smoothly, which is fine. Yeah. But then you got 3 MCPD, that's what Peter told you. Or, well, that's what we have seen. Or they're using the mineral oils, yeah, to make just sure that their plastic foils just rush quickly, yeah. And then you have much more contamination. And it's really regular, it's both MOSH and more. A little bit difference in both fractions maybe, but yeah. So that's what we've seen. And that's what we had in the beginning with our sample vials. Yeah? So we first started with the 3 MCPD, and we always had background in the 3 MCPD samples. In the norm, it's mentioned that you should heat the vials. We know now why. And we asked the supplier how they pack these things, and they said, yeah, we're using vegetable oil, so it's not, yeah. Okay, we asked them to change it. They did, and now it's the other way around. So now we have the more content into this vials. But yeah, usually it's both that you do, and it's one run, so that doesn't really shorten any runtime.
And for example, if we send a sample to laboratory, which measure that we can take it to prevent to get wrong results? For example, the temperature or the packaging or...
Yeah, that's a good question, how to prevent you from wrong results. And by a Gerstle system, and it's no, that's something, yeah. Usually our lab, and that's what we've done here in the past, we take part of in the round-robin tests in the European Union, yeah, or in Germany or European Union, that depends a little bit. And if we present these solutions, then we are sure that it works, yeah. So we have a application team behind this one here. So we even did more than 1,500 stability runs to show that the system will stay in condition. Yeah, so you see the performance is dropping slowly until 1,500 injections, 1,500 injections, but it's still in the way that it can work, so that's acceptable. So that's when we stopped this test You just wanted to make sure the system is reliable, so for you. And it's the same with the round-robin tests. From time to time, we attend to these round-robin tests. It's a little bit depending on the metrics for sure, yeah, but usually. And the other part is that we have this German lab which is just doing much more. So if there is any problem with the sample or it's a difficult metrics, yeah, usually they will just, we just use them as a reference and ask them what's going on and where to take care of. But our application team is now working with this one more than 5 years, and they're running these samples. We're running even customer samples from time to time on request. Yeah. And if you have a sample with a known content, you can send it to us, and then we just can compare it. Yeah. But this is a little bit communication with precision electronic, yeah, so that we can handle these samples and not hundreds of samples, just 1 or 2 maybe. Okay.
Thank you.
Any other questions? Okay.
What about helium consumption? Because I see that we have interchangeable, we have vapor exit. I imagine that it's consumption.
So this is a secret, no helium consumption. We're using hydrogen as carrier gas.
Okay.
To keep it easy, yeah. But for sure there is a helium, hydrogen detector inside, yes. So if you have a problem with hydrogen, but we're using hydrogen as the carrier gas.
So the solution is solved with a hydrogen generator? That's it?
That would be the part of our distributor. So we're not selling everything. So, but yeah. So anyway, the chromatographic equipment would be part of precision electronic. Yeah. So they will sell you the GC, the LC, whatever you're going to buy. The GC needs to be modified. So that's what we have to find out with precision electronic, if they can do it or if we will do it. So usually the first systems into a new country, we ask the people to ship the GC shortly to us because we're going to modify it. Then we will ask the service technicians to show up. They get an introduction how to do this correctly, what to take care of. Yeah. And usually with the system, there is a 3 days training sold for the customer as well. And this will be done firstly from Gerstel, yeah, until the application chemists from our distributors can do this as well. Finally, the goal is that you have just one partner in your country, which is responsible for everything. Yeah? But for the first systems, so Tunisia is a new area for us here at the moment, that would be that we modify the GC and send it back. But the GC setup is done in our headquarters. We do a checkout of the complete GC equipment so that we are sure that all this evaporation of hexane and dichloromethane will work. Yeah? And if this works, we're going to pack everything and ship it. And the same system will be done here again. So we had just a colleague going to Jakarta, so for 5 days or 5 days for installation. So they're traveling around the world.
Donc, de point de vue commercial, donc c'est en fait Précision Électronique comme distributeur d'Agilent, c'est lui qui fournit l'HPLC et le GC. Ils sont envoyés à Gerstel, ils vont faire les modifications nécessaires et ils vont donc tout mettre au point, tout optimiser, tester l'instrument, éventuellement former les utilisateurs sur cet instrument, sur cette méthode. Et après, quand ils sont envoyés en Tunisie, ils sont encore vérifiés. Et bien sûr, donc vous aurez la double assistance. Concernant le GC, l'HPLC, c'est l'équipe actuelle de précision électronique. En attendant, bien sûr, que et la partie application, la partie logicielle, la partie application sur cette technique, ça va être assuré dans un premier temps par les ingénieurs de Gerstel, en attendant que l'équipe de précision électronique, bien sûr, soit informée. Mais le premier temps, ça va être comme ça. Donc, en fait, on a choisi cette option, on voulait, pour minimiser le coût. Le fait que nous sommes des distributeurs comme eux sont des distributeurs. Donc, eux, au lieu d'acheter les GC et l'HPLC directement de chez Gerstel, parce qu'eux, on les achète pratiquement au même prix, mais eux, ils vont rajouter leur leur marge qui n'est pas la même que celle que nous faisons, nous. Hein. Donc ça, c'est la meilleure solution, c'est-à-dire nous, on achète la partie GC, HPLC, on l'envoie, et ils font toutes les modifications. Bien sûr, il y a le surcoût de l'HPLC et du GC, il y a le surcoût de tout ce savoir, et cette optimisation, cette modification de l'HPLC et du GC, et cette partie, cet automate, l'automatisation donc, de cette technique. Et la formation et l'assistance, etc. Mais Gerstel, il garantit l'application. C'est-à-dire votre application, elle doit, comme l'instrument, il est garanti pour qu'il fonctionne, la méthode, elle est garantie pour que vous obteniez des résultats. C'est-à-dire que ce n'est pas un système ouvert qu'on va optimiser avec vous, qu'on va tester. Non, il arrive, il est fonctionnel comme vous le désirez.
And for this analysis, how long does take this analysis since the reception of sample until we get the result?
So the sample preparation sequence for saponification in the offline version is 36 samples. Per sample per day, so that's because of the long time that it needs for the sample preparation. If you have just a simple run with a allox cleanup, the sample preparation is around about I think it's about 20-25 minutes per run. So this is after 25 minutes, then you should have a result. The LC run is not really 16 minutes, something like 16 minutes, which is required, not longer. I have to go back to the chromatogram to have a look. And the GC run is around about, I think something about 20-25 minutes as well. So that's all in all the time. It's a little bit overlapping. That will work. So for the saponification, we know that we can do 36 samples per day. And the system which is injecting the samples can run this as well. If we have an online system for saponification, what I talked about in the beginning, that it's possible depending on the sample, then it's even less than we have just 18 samples per day. Yeah? But 24/7 and at the weekend as well, so it's the system will not need to go for sleep or something. That's the advantage. So you come back on Monday morning, have a lot of work to do because you have to check the chromatograms.
And we can analyze just one sample, or we need to collect, for example, 6 samples to get the result.
You can analyze one sample if you just have one sample. Why not? There's no need to collect it. So you get the result a little bit earlier, but it's up to you if you collect 6 samples up front and then use them or just run them. It's a little bit depending on what kind of samples you get. So some of them don't need saponification, so there is no need to put it on this cycle. So you can set up a second run without saponification, choosing a different method, without saponification, and then you can use whatever 3 or 4 samples without saponification and the other one again with. But single run is possible as well, why not?
Okay, thank you.
Ça va être 20 minutes, 25 minutes. Parce que pendant qu'il analyse le premier, il est en train donc de préparer le suivant. Donc les analyses, ils vont plus vite. Mais en durée, c'est la même chose. Hein. Mais c'est juste ce chevauchement. Et éventuellement, comme il a dit, il y a l'étape de saponification qui est assez longue parce qu'il faut la faire à part ou dans un système online, donc ça va prendre. Donc, parce que la saponification, c'est du temps, hein, c'est le kawash qui va faire la saponification. Après, il faut faire l'extraction liquide-liquide. Voilà, comme ça. Exactement. Parce que saponification que pour les huiles. C'est pour séparer les acides gras, tout ce qui est saponifiable et rester la partie, parce que les huiles minérales ne sont pas saponifiables. Donc c'est juste pour pouvoir se débarrasser de toute la 95% de la matrice qui sont les triglycérides en fait, pour s'en débarrasser, pour garder que la partie insaponifiable. Mais pour les autres matrices, on n'a pas besoin. Les dates, tout ce qui est emballage, par exemple, vous, si vous êtes dans les dates, donc vous allez avoir aussi l'emballage, et avec le risque que les MOSH migrent du package de l'emballage vers les dates ou vers un autre. They analyze date.
Yeah, it's possible.
Saponification. We don't need saponification.
No, there's
C'est
no.
logique, on n'a pas besoin de
So
saponification.
this would be epoxidation maybe and allox cleanup, yes.
Merci beaucoup pour la présentation. Juste une question pour l'identification des molécules. Dans la présentation, il y a identification du C12 jusqu'à C50. Mais dans la norme, elle dit de C10 vers C50.
Non, dans la présentation, en fait, ça c'est pour dire que pour l'intégration.
Oui, pour l'intégration.
Pour l'intégration, parce qu'après, il faut les éliminer, tout ça. Juste pour l'intégration, donc on a les différentes zones. Les premiers, parce qu'ils ne sont pas sur la bosse, là, donc c'est facile à intégrer. Et après, quand ça monte donc, sur la bosse, donc il y a les pics jusqu'à C50. Et la difficulté, c'est comment les intégrer manuellement.
Oui, l'intégration, normalement, à partir du C10, non C12. Dans le tableau, si vous retournez à la présentation.
On peut revenir en arrière, s'il vous plaît, pour l'intégration. From C10, 11, until C50. Until C50. Non. Ah, ça c'est le PFAS, on est lâché.
Sinordine,
Hein?
j'ai posé cette question puisqu'il y a une différence de valeur entre les laboratoires lorsqu'on
Oui.
fait les analyses.
Justement, les différences entre les laboratoires sont dues à cette intégration manuelle. Et j'ai dit tout à l'heure, l'avantage de la solution Gerstel, c'est cette intégration automatique. C'est ça, hein? Donc, ouais. Non. At the end, I think. At the end. Ouais, déjà, ça. Si,
Non, dans le tableau.
encore. At the end. Yes. Donc déjà ici, hein, cette partie-là, elle va être éliminée. Hein.
Oui.
Encore. Ouais. Il y en a. I think the comparison between manual and automatic integration. No, at the end, I think. at the end.
In the end.
It's in the end. It's not really shown. But we can discuss this in the break.
Okay. نشوفها من بعد وليد. En tout cas, la première partie, c'est éliminer donc, les alcanes, hein, c'est jusqu'à C50. La partie au niveau de l'apparition donc, des MOSH et MOAH. Donc il faut les enlever. Et après, donc, pour l'intégration, on va... Go to the, yes, yes. Hein? Donc, تشوف هنا tous ces pics-là, il faut les intégrer. Et c'est là la difficulté, c'est d'intégrer tous ces pics qui sortent de cette bosse. L'erreur, parce que si on le fait manuellement, on va faire beaucoup d'erreurs. Et le tableau de comparaison entre le manuel et l'automatique, là où il y a les 5 utilisateurs, parce qu'ils ont fait une intégration automatique, et 5 utilisateurs, ils ont fait l'intégration manuelle. Et là, on a vu donc la différence. Bon, il y a des utilisateurs qui ont bien intégré. Mais ça, bon, ça dépend aussi.
Ça dépend.
Donc l'erreur, encore. Go. Donc vous voyez, tout ça, tous ces pics-là, en gris, peut-être ils sont en gris, tout ça, il faut les intégrer pour pouvoir les éliminer. Parce qu'on intègre, dans un premier temps, on intègre la totalité, et après, il faut enlever tout ça, si on le fait manuellement.
Même il y a une influence sur la ligne de base.
Oui. Donc, mais il faut faire par soustraction. Sinon, la solution de Gerstel, c'est de faire l'intégration automatique de la bosse, en fait, sans tenir compte de ces... Encore Nada More. Reported the end.
It's reporting from C10 to C16 and then we start at C10. That's what we
Ouais.
C11 is the one we use for the determination of if the evaporation is.
Ok, on peut discuter éventuellement, mais c'est vrai, c'est un de la difficulté de cette technique, c'est cette intégration. Et c'est là où intervient l'expertise de Gerstel, parce qu'ils ont développé un logiciel pour permettre cette intégration automatique.
So if you're really interested how this integration is done and how it starts, then I would suggest that we do a short Teams meeting with one of the specialists from MOSH. That's much easier, and they can online show you at the Teams meeting how this is really done. Yeah. Showing software and integration here and everything is really a little bit difficult.
It depends.
Yeah. But anyway, if you're interested, then just ask. We can set up a Teams meeting. That's quickly done these days here. And then we can ask one of the specialists and you can ask the questions. So then they can show what's going on and how exactly it's done.
Okay, thank you.
Yes, sending samples would be possible.
Dans un premier temps, d'envoyer donc un échantillon pour qu'il soit analysé.
Bien sûr, Anna.
Okay, so I'm expecting a lot of samples.
Okay, thank you.
Okay. Yeah, for sure it's possible. It's a little bit discussion with you about the number. So yeah. Yeah. So but it's possible. That's not a problem. We're doing this for the customers, and usually, if you're interested, then you can send samples. But on request, please. We just handle this step by step.
OK. D'accord, donc c'est le temps de... c'est le brunch. Donc après la pause, c'est pas un déjeuner, c'est un brunch, donc on va manger, donc pas un repas, c'est un brunch, juste comme ça. Et on va reprendre après pour le PFAS et les microplastiques. Hein? Non? Ah oui. Ah d'accord. Ah non. Ah. Kaç nokta mı? Hein? On a dit ça. Oui. Non. How much will take? How much will take? نفس الساعة le temps que traiteur donc nous avons encore une petite présentation concernant cette technique d'extraction qui est stir-bar, simple extraction. Maintenant, une technologie qui a été développée par Gerstel, comment extraire, en fait c'est une technique inversée, SPE, hein, reversed stir-bar. Maintenant, au lieu de faire passer l'échantillon à travers une phase stationnaire, on va introduire la phase stationnaire dans l'échantillon. Cette phase stationnaire, elle va capter les composés et on va récupérer cette phase ou c'est comme un agitateur en fait, hein. Donc comme un aimant, il va extraire, il va capter les produits et après on va donc les analyser. C'est une technique développée par Gerstel. Donc normalement ça dure 1 heure, mais je lui ai demandé à peu près en une demi-heure, le temps que... Oui, donc merci de remplir. Oui. Juste pour nous permettre d'évaluer donc cette présentation, cette journée. Et n'oubliez pas pour ceux qui doivent partir ou une chose comme ça, de récupérer la présentation. Donc, merci.
OK, ja, je présente.
Ouais.
Vite, parce que nous avons faim. Application de l'extraction par SBSE avec GC Maspec pour l'analyse de l'eau. Ne c'est pas boire, mais analyse par le laboratoire, conformément à la directive cadre sur l'eau de EU, Europe. Presented by me and done by colleagues of mine. SBSE, qu'est-ce que c'est? Gerstel Twister, qu'est-ce que c'est? So, the SBSE, c'est inventé par un groupe de professeur Pat Sandra de Belgique, Université de Gand. Et à un moment, il y a plus de 2000 publications scientifiques de SBSE. C'est le twister, c'est le stir-bar sorptive extractive. C'est un noyau magnétique, très petit, et revêtement de verre, de glace, et c'est une couche de PMS, polydimethylsiloxane. Il y a aussi un éthylène glycol twister. C'est la métrique die how big and how thick it is. Important, c'est the amount of PDMS, which is important, c'est très important. And if you compare this with SPME and SPME arrow, you can see that the amount here is a lot more than the amount on the SPME. So it's very easy to understand that the extraction with the twister is far more precise than SPME or SPME arrow. And that is the important that to understand, because a lot of people, they do headspace, they do SPME, but they don't know about SBSE, so working with the twister. And this is here to show how easy and how practicable it is to work with the PDMS twister. So this is how you work with this twister device. So c'est très simple. So this is the how big the twister is. So it's very, very small. That is how you sample. You just take 100, so 100 milliliter de l'eau, and you put it in the bottle, and you place the bottle on a stirring plate. And then you stir automatically. So typically the lab, they bring in the samples in the afternoon, après-midi, and they put the sample on a stirring plate, and they let it stir overnight, because you never can stir too long. You can stir too short, but you never can stir too long. In the morning, they take the stir bar out. You can even clean it, dry it if necessary, and there you put it in your automated sample. Prêt à être placé dans le plateau de échantillonneur automatique. And that's how you work with it. That's how you only push the button, and then you put it in more or less in your GC. So in the GC there is an injector. So this is the PTV, the Gerstel injector. And on top there is the TDU, so the thermal desorption unit. I have a small one here, that is here on the table, you can see. Here it is, very small. Yeah. So this is on top of the injector. Yeah, and on top of it, you put then a liner with a little twister in there, and that's being done automatically. And then it runs all the tray of the twisters. Yeah, I will show their twisters here. So this is what is happening inside of the TDU, where the twister is. And this is then more or less the liner of the injector. And then it goes automatically through your column into your GC. So very direct and very, very simple. So with this, you have the possibility to transfer 100% of your analytes directly from the thermodesorption into your injector. See, that was the TDU. Here you see your adjuvant GC. There is the Gerstel Robo again. So it takes then the sample from the tray, puts it in the TDU, examine it, analyze it, and at the end takes it out again, puts it back and take the next one. So the lab that is analyzing, they're analyzing then in the morning starting, just push the button and it will work every time. Take the old one out, put the new ones in, works through the day. So a very, very enjoyable and very easy way to work out your water samples. You can more or less calculate the expected result, because every compound that you want to analyze, they have an octanol water coefficient, and with this you can theoretically more or less calculate what will be the recuperation. No? But that is of course by theory, because it's not only that compound in the water, there are other parts in the water. But you have an idea what the recovery is. So this is a freeware that we can share with you, that you can have an idea of your compound, if it will work with the twister, yes or no, because it's all about the polarity of the compound. Now, it has to stick to the little twister, which is covered with the PDMS, polydimethylsiloxane. And in that way, you can expect the result on a twister steerbar. But it is a little help. And then you can see more or less the octanol water coefficient and start the calculation and see the recovery. And see the size of twisters, because we have different sizes, length and thickness, which you most likely then need. So there was a European Water Framework Directive developed by the European Commission in order to do this kind of analysis. And we showed that with a number of compounds, so over 100 compounds, so priority compounds, that it is possible how to do this and how easy to do this. So they are these detection limits, or the limits of quantification. They are then done in the whole water sample, including also the particles in this. This is a cutout of this directive, and it is, you see some of the compounds that are mentioned in there. There are pesticides, and there are also, you can see later, PCBs, PAHs. These are all in these priority lists. So a list over 100 compounds. So the objectives of this research was to get all the compounds in there. Of course, to use these twisters, this SBSE, and of course to get in the neighborhood of this limit of quantification. And of course, the end, garder la méthode, aussi simple et direct que possible, because that is what we all want, very simple and very precise. This is some of the compounds. In total, there were over 100. But as I mentioned, there are pesticides, there are PCBs, there are PAHs in there. And that is what people mainly, when you analyze drinking water, have to do. You have to do these kind of compounds. Nous avons sélectionné over 100 dans le domaine de l'analyse de l'eau de surface. So the surface water and the drinking water. In the break later on, I will show a little video made by Viola Environnement in France, because they use this a lot. For instance, analyzing the drinking water of the city of Paris. That is being then done with this SBSE. This was the final method, méthode finale. So you can do 2 extractions. And again, you never can prepare too short. So here they did then extraction of 17 hours, but that can be overnight unattended. It's just stirring. And once you stir it, the compounds are on the twister, and then the twister is put in the desorption liner here. Whoops. And this is put on the tray over here. Yes, that is where then this liner is with the twister. And the autosampler every time takes a liner with the twister, puts it in, analyze it, afterwards going back and take the next one. So totally automated. So we take 100 ml of sample. And if you calculate it down, it means that you can do 10 picograms per injection, which is of course then very low, but that is what they want. They wanted to see that. Nice thing, of course, you don't need that much water. In fact, you don't need to store that much of water. With the method, we only need this 100 ml, and that is easier to store rather than 1 liter of sample. So that is an additional advantage. So how works the method? And here you see then the limits of quantification. And the limits of quantification needed is, you can see it's very low. You see? And these are all these compounds. You see the PCBs, the pesticides, the PAHs. Again, that is most likely also what you need to analyze if you analyze drinking water. And here you see some examples where we did then, for instance, this dichlorvos, so pesticide in river water. And you can see then here, oh, that was too fast. This one, the river water, yeah. So you see that required is 0.18 and we reach 0.073 nanogram. So far more better. And the next one, for instance, is benzoapyrene, so a PAH in mineral water. And again, you see here, it's a nice example because required is this. And we reach this so low. Similar for this one, the sibutrin. Again, you see what is required and what we mentioned. And of course, on here you see then the calibration, of course. But yeah, these pictures are always promising. Another one, DDT, para DDT in river water. Again, you see what's required and you see what we reached. But not all were very good. There are also some that cannot be reached very good. This is still being reached very good. Again, the limit of quantification, what is needed. And you see what we reached, very good. Also a good one, here a pentachlorophenol one in the water, mineral water. So you see the precision of the repeated analysis. Below you see all the compounds here. Now, this list of over 100 compounds with an average RSD of 6.9%, so not too bad. The trueness, veracité, spiked mineral water. Again, below you see the compounds. So you see the average deviation taken from 100% is 7.2%, so also not too bad. But you see there are differences in there. No? There are compounds that are better than the other ones. They are not all on 100%. The particles can also be then sampled. That is where you take a reference sediment and you put an internal standard in there. You twist it and you can even heat then your sample and see then the analysis result. So here it's confirmed the extraction of the particles that are in these. So an expected analysis value and an experimental analysis value, and they have to be, of course, quite similar. Some other compounds. This is water from the river Ruhr, where we are located in Germany. And this was is the company, the EWW Water Center. And they did here a spiked water, river water sample. And you see what, it spiked was 0.5, and you see what was reached with the long list of compounds there. So here, more or less, you see the different channels, the sewage water treatment and the tap water. So that's where we did, you see the number of compounds that were found here, where the limit of quantification was defined. And over there as well, and over here as well. So the conclusions is, l'utilisation du twist est utile pour l'analyse de l'eau. Part is European Water Framework. The limits of quantification are very low, and you saw nearly all ones can be reached by that one. I don't want to reach everything, but we have a lot of customers, especially in Spain and in France. So, nombreux laboratoires en Allemagne, Espagne et France, they utiliser avec succès Twister pour les travaux this European Water Framework, and in other countries as well, because then they look at this European Water Framework. We had requests, for instance, from Saudi Arabia, where they wanted to analyze the Zamzam water, so the holy water. So we are talking with them. So there's interest because it's very easy to use, very simple, and it's very so less time consuming. And yeah, the sample preparations can be done overnight. So the take-home message, so the Gerstle twister analysis with the thermodesorption together with the adjuvant, GC mass spec, is a very powerful combination for sensitive water analysis. And that is that was my last slide. So thank you for attention. Any questions before we hasten down the break?
C'est une technique très, très intéressante puisque ne nécessite pas de préparation d'échantillons. On a besoin juste de 100 ml d'eau, introduire ce twist. Ils sont là.
Yeah, in there.
Donc on le laisse agiter pendant 17 heures, on va voir la nuit, pendant la nuit. Après le prendre et le mettre dans un autosimple ou directement le placer à ce niveau-là, et il va y avoir une désorption. C'est juste par rapport à un GC que vous connaissez, juste il faut ce type d'injecteur. Donc ce n'est pas un injecteur standard, c'est un injecteur développé pour cette application. Et donc là, on peut atteindre, moi j'étais étonné, franchement, donc je travaille avec vous, la plupart, donc pour l'analyse des pesticides. On est à un ppb, là on est au ppt, c'est-à-dire 1000 fois plus sensible que ce qu'on cherche dans les huiles. Mais grâce à ce module-là, donc c'est une technique de adsorption, donc on adsorbe, on colle les échantillons, donc tout dépend de la nature de la phase qui est là. Donc tous les composés sont adsorbés, après on le retire et on l'injecte ici. C'est une désorption par la température, une désorption thermique. Donc on chauffe et les produits, bien sûr, ils sont volatiles, ils vont être introduits dans le GC. Et là, avec un GC MS, on peut descendre à des limites inégalées. Moi-même, j'ai l'habitude de travailler avec le ppb, mais là, on est au ppt, c'est-à-dire 1000 fois, voire plus sensible. Donc ça, c'est une technique grâce à Gerstle.
So the sampling, so préparer is very easy because you can even sample at source. You just take the twister with you, go to somewhere where you need to analyze the water. You just need a glass and you put a twister and a steering plate, but the steering plate can work on battery. And you can steer somewhere and take the twister to your lab. For instance, Veolia Environnement, they have the lab in Paris, in France, but they have also a sample site in Sweden. And he took just the twisters to Sweden. He sampled in Sweden, took the twisters with the airplane back to France, and he analyzed. And he could show what was in the water, because the tap water was smelling funny, and they want to know what was the cause of the bad smell. And he could show what was sampled in Sweden and analyzed in France.
We can use it for olive oil.
So
we can use it because there is application. Mr. Hazem asked for SPME, micro SPME. Des composés volatiles de l'huile d'olive. On peut les piéger ici et éventuellement les analyser aussi.
Well, you have to know the compound if it feels affected to the PDMS.
Oui, PDMS.
No? Because it's all about the polarity. No? And then it's being on there as well.
C'est une application typique de l'eau, donc un acétate. C'était au laboratoire central, donc ça peut être intéressant. Donc une centaine de composés extraits avec ce module, avec des limites de détection, donc incroyable. En plus, c'est facile. Vous pouvez ne pas ramener l'eau au laboratoire, vous pouvez faire l'extraction sur place. Donc il faut avoir juste un système d'agitation.
Yeah.
Donc vous faites l'agitation, vous récupérez, vous rentrez au laboratoire uniquement avec ces barreaux en fait.
Yeah.
Ces barreaux.
So another advantage of using the twister is that you can reuse it. So you can, when you work with drinking water, so you can clean the twister afterwards by heat, for instance, and then you can use it again. So with drinking water, you can maybe use it over 50 times or something like that, because it's very rugged, very easy to use. And if you compare it with SPME, you have the fiber, but the fiber is very expensive. And so the stair bar only costs 1/3 of the cost of a fiber. And again, it is very more easier to use. As with the SPME fiber, you have to watch out that it doesn't crack the wrong speed, and and then you have to invest more money. With the stair bar, it's very easy, very rugged.
C'était au laboratoire central. Ouais, ça peut être une solution.
Okay, fini.
Des questions? Merci.
Jo.
Merci, Monsieur Peter.
Allez,
Donc,
tout.
on vous invite à une connexion. Hein? Vous êtes là? Super. Juste pour l'histoire, l'inventeur de ces barreaux aimantés, il y a quelques années, chaque année, il est invité en Tunisie pour faire des séminaires. Donc maintenant, il est à la retraite, mais c'est lui l'inventeur, c'est M. Patsandra, professeur Patsandra. Donc il a développé cette technique. En fait, c'est l'inverse de la de SPE, Solid Phase Extraction. Donc en fait, c'est l'extraction puisque la phase, elle est là, elle descend et après, on la récupère. Donc,
So, guess everyone is back from the short break, from the nice food we had and drinks. So I like this, I must admit. I will be responsible for the last two talks here today, and yeah, we're a little bit behind the schedule, so I might try to accelerate it a little bit so that we can be in time for going home. First talk today, or for this afternoon, will be PFAS analysis. So PFAS analysis is showing up more and more. The request, we started already years ago to develop a method for water. So I know that Agilent has a solution for water samples as well. So I'm going shortly through this topic. What existing methods are available, and then I will just talk about what we did and the modification we did and why we did it. Yeah, so that you know what's the benefit of our solution. By the way, Dr. Thomas Brunch is the application chemist who did this one. He is on vacation, so that's why I'm here. Let's generally talk about PFAS. So they are present everywhere. They have been developed, I think, in the early 70s. That's when the first coated pants showed up. That spooky thing in Germany, no one trusted in this one. Now these days they are present everywhere. In general, it's a long chain carbon connection with fluorinated, more or less complete fluorinated. There are different kinds like the carbon acids or the sulfonic acids as well, or what you see, the polymers like Teflon, yeah, which we all know. So yeah, that's where you find all the things. What I didn't know that, for example, in the firefighting foam, yeah, this is a lot of PFAS, and that's why a lot of problems around the world exist, especially at the airports. So in the United States, they even practice with the PFAS foam. So they have a lot of contaminant of the groundwater, so up to 1,000 ppm. So this is not really trace analysis, this is just tasting. Yeah, so the food packaging here from fast food, it's coated as well. So I think about using McDonald's or whatever. I'm not sure. What we have in Germany is the reusable food packaging here. So for it's not for single use anymore, so you can clean it, but they are coated. It seems to be that they are coated as well. So just to make sure the lifetime is extended. For the ladies here, cosmetics, lipstick, mascara. So take a look where you find these PFAS everywhere. Yeah, why are they critical? So usually they're used to known or just suspect that they can cause cancer, thyroid disorders, or hormonal disruptions. So fertility is going down. That's what a study just showed, and that's why people are taking a close look at the content and what is in. Yeah, so trick on this kind of analysis is the long chain PFAS. They will stick to every surface they can find, even particles, whatever is there. So you need to find a method to get them into your sample vial without any loss. So taking sample means you're taking a half a liter of water, and then the European norm tells you to at least add 30% of methanol. Usually in Germany, we're adding 50% methanol, so we have a 50-50 mixture of sample and methanol, which means that it's already a lot of methanol you're using. So with methanol, there are some problems showing up. In our method, we will add additional formic acid. I talk about this a little bit later. And we use a different elution solvent to elute this from our into our system. So 3 methods are available. So usually the direct injection, this is well known. So you can inject up to 100 microliter. The sample itself will need to be diluted during the injection by, again, 50 microliters, or you have already diluted it with 1-to-1 methanol. So the effect is that you have a 50 microliter real injection, not 100 microliter. The 100 microliter is diluted already. Then there is the option to do a small enrichment with a HPLC pre-column. So you just put a small column in front of your analytical column where you can load your sample and maybe enrich it a little bit. That's a little bit limited. We will talk about this. And the other one would be a real solid phase extraction. So you can use up to 50 milliliters of sample and do an enrichment on your cartridge and later elute it into 500 milliliter extract. Yeah? And then you can do a regular 10 microliter injection into your LC system, which in effect would have a sample amount of 1 ml of your sample. Yeah. If you calculate this. This, for example, is a setup which is used with a pre-column. So you have an injection. If you use a loop or an Agilent sampler, which is just pulling it up into their device, it doesn't matter. So you need a pump, an HPLC pump, to transfer this to the pre-column, and an additional valve to select where your flow is going. If you do an enrichment, you make sure that the most of the flow is going into waste. And if the enrichment is done, yeah, the large volume injection is done, then you can switch the pre-column to the HPLC column. And finally to the mass spec. That's where we want to end up, or MS. Yeah, so there's some limitations. So advantages, first of all, the enrichment, that's what we talked about already. the sample cleanup, yeah, it's not really a cleanup what you would know from an SPE. So you're not changing the solvent, you're not changing everything. So you can modify it slightly and slowly it will help. But the major point here is that you protect your LC column, which might be very expensive. So if you have matrix going to your LC column, then that's an expensive experience you will have later on. The limitations, yeah, cartridge is used multiple times. There is no way to exchange it quickly, so you have to stop the system, you have to remove it, you have to put another one in and condition it again. That's a little bit the disadvantage here. The additional pump which will be used for this system is optional. You don't need this one, but usually you make sure that your analytical column has flow all the time to make sure it's equilibrated all the time, that there are no pressure switches on the column. Yeah, the interactions of this column need to be of the same time as the HPLC column. So you're not going to change the polarity of your effluent. That's not possible with this system. So the other part would be an offline SPE. So this is showing here a schematic of a Gerstel offline SPE, because this one is something I can show you. The other one I need to get the permission from other suppliers. We have different steps here: conditioning, activate the surface of the solid phase extraction cartridge. Then we can load the sample. We can change the solvent and wash away the matrix. Yeah, just make sure that our compounds of interest, the PFAS, will stay. The dry step offline is possible, so I can now change the solvent from a whatever organic phase, maybe into a LC gradient phase. That's possible. Yeah, and then elute it to a sample. Problem here is that we are talking about yeah. So what the advantage here is the enrichment up to 50 ml sample. So you can have imagine that we have a lot of sample we can put on this cartridge. We have here a really clean up, so we can change the solvent polarity just to make sure that the matrix goes away, and this is important later on to improve the detection limits. Yeah. And I can use any kind of cartridge here, so I will talk about the cartridge we are using in our system, but that's independent from the interaction of the chromatographic column later on. Yeah, disadvantage on SPE, that's what we talked about today already, is that you have to sit in front of your cartridges. You have to be there all the time. You have to add your sample up 50 ml. That will take some time, maybe 20 minutes, half an hour, or an hour. It's a little bit depending. Yeah, as you have an open system, you're filling in anything. There's always a possible contamination. So that's external source, someone's passing by, or you're changing your vessel, whatever. That's a problem. And for sure, that's one of the most critical things in sample preparation. If you have an online system and a sample preparation system, that's not prone to human errors. What happens usually, the Monday morning samples you have, that's a different kind of the regular ones, because people return late night from party, whatever, so that can happen. So the question here, it's showing up in the wrong direction, was how can we combine all these advantages and eliminate the disadvantages of these systems? And that's when our stuff here, we had this system which is called Spexus, already in use for ampha glyphosate, the same setup. They just decided to see if they find a cartridge which we can use with this system. So we can have all these advantages here, like the direct injection, the automatic sample cleanup, and all the things we have seen before in one system. Yeah, you can even do a direct injection like you do with a Agilent LC, yeah, just passing by the system. It's just a valve switching, selecting the correct method. So you have the choice of doing both. So the system is called Gerstel Spexos, SPE, XOS means online system. And it's directly in line with the LC and with the sampler. That's the general process here. We use our sampler to load the sample. We will later see that we even use the MPS upfront to do sample preparation, dilution, extraction, whatever is possible as well, so that you don't have to do this as well. That's possible. Depending on the sample size, and we have done this from soil extraction and sludge extraction, so that's fully automated. The customer puts the sample on the MPS, and the rest is done automatically. Yeah, we can load the cartridge. We will do this several times. In our system, we load the cartridge 3 times with 0.5 milliliters of sample, diluted in an additional 1 milliliter water, half a milliliter water, sorry. And then we can directly elute, in case of water, for example, this is not a problem. If we have matrix loaded samples from foodstuff, which is possible, then we can wash this cartridge. We're just not in line with the HPLC at this moment. We can change the solvent quickly because our device can deliver several milliliters a minute to clean this cartridge, and then later on elute it to the LC. So the typical steps of the SPE can be handled. Just a short intro here. Cartridge conditioning, that's what you usually do. Then the sample load, and the cartridge wash here using different solvents is one of the big advantages. We can really wash away the matrix because we have different interactions now. We change the solvent for the matrix solution before we elute the compounds. Yeah, the sample elute will later be done with a LC gradient pump. We just have a small trick in between because we're adding a different elution solvent as well and dilute it with the LC gradient. That's a short overview about the system. To the right, it's the LC MS. Then from right to left, it's the Spexer system and the regular LC setup with the binary pump and the isocratic pump. The isocratic pump is used for the elution of our system later. And for sure, the Gerstle sampler with samples and injection valve. Yeah, that's the main part, which is called Spexers here. It's divided. Looks nicely. That's really nice. So, but in fact, we have a lot of valve systems here in the system. Can I see this here? Usually 3 valves. Here, the 4th valve is installed in our application lab, and upstairs we have a high pressure dispenser for delivering large amounts of solvents at a time to wash cartridges and do cleanups. So the cartridges here, that's what you haven't seen. We have some cartridges around the table. They are really small. So at the moment they look very big, but it's not. So just to give you an idea, that is a tray with 96 positions, sorry. There's a second tray available here. That's a free space you see next to it. So up to 192 samples can be done in a run. Cartridges, depending on the matrix, can be reused. For water samples, there's the option to reuse them. Depending on the food samples or what we've done with the sewers water and sludge extraction, that's not possible. So if you use it a second time, you will see it's blocked. But anyway. But just to have an impression how large the cartridge is, that's just about nearly a centimeter. These cartridges up pressure stable to 1000 bars, which is nice that you can run this directly in line with the LC. And yeah, usually it's a single-use part depending on the matrix you use. Yeah, what we decided that we just had to look for a different cartridge which can keep the PFAS, and yeah, we should be able to remove the matrix. So we choose here a VEX cartridge, a weak anion exchange cartridge. So as the sample is done in methanol, so we add some formic acid to the methanol to keep the pH low, so that the interaction of the VEX phase is ionic, positive charged, and they will keep all the PFAS, even the small PFAS will be trapped there. They will be retained on this cartridge. So we load this cartridge 3 times, and the last step for the system here is that we have to elute the vial with a polar compound. just to make sure that everything sticking to the walls, sticking in the lines of the online system, will go to the analytical column. And that's when we just inject a mixture of ammonia and methanol. Sorry? No, that's the wrong way, so it's a little bit too fast. So what we do, we just use this mixture of ammonia and methanol, and if you just route this to your analytical column, that's worst case. Your peak shape will look like hell. So what we do in between, we dilute this with the LC gradient in a special valve. We mix it. That's what Agilent does with the direct injection. It's an inline injection into the running LC. And this will dilute the ammonia, and what will happen is that the elution of the cartridge is done very quickly, correctly, and the analytical column is not affected. So the result here, and it's especially the two peaks here in front, which if the elution is not done correctly or the ammonia methanol would come to the column, yeah, then they would look quite bad, so a little bit broad and flat. But this shows now that the elution here is done very correctly. The peak shape is quite nice and can be easily integrated. Usually that's a standard here, 50 nanograms per liter, so you have nice peaks here, it's good visible. And what's part of the method here that's showing, we just ship all the MRMs and the complete method with the system. So there's nothing for you to set up, maybe correcting a little bit the retention times, that's always needed, but that's all. So what's more important is now the linearity of the system. So we have a wide range where we tested the system up to 2,000 nanograms per liter with the R2. It's quite nice here, but what's more important, that's where we expect the samples here in this range, in the range of 0.5 to 25 or something like this, or 50 nanograms per liter. The linearity is even much better. So you see 3 nines and a 6 here. That's really nice. So this is the recovery of all the compounds here. You see at 1 nanogram per liter, the recovery is a little bit too high. But this is because we are just at the edge of the detection limit. So that's the minimum we need to achieve. So the RSD here is a little bit higher, and the recovery rates calculated are a little bit higher as well. But as soon as it comes to a content of 5 nanograms or 25 nanograms per liter, these rates are just below, around 100% or a little bit below. So all the compounds we did here, and that's much more than we see here, can be detected, and the detection limits, I hope this is, and the detection limits here are given. The calibration range we used here is from 0.05, so 10 times lower than expected, or than, not expected, on what's in the norm. The only problem, and it's what you already see here, and people just might ask, that's the PFBA and the whatever. Yeah? So this is the blank run of these compounds will show you higher content. And that's the problem what I told in the beginning, even with MOSH more. The solvents have to be very, very clean. So we are not sure what happened here, but we have done it with different solvents. It's always the same, yeah? And it's not from the system, so we have tried several things. But yeah, the only way here what we can do is calculate the lower detection limit by using a calibration curve and then calculating it down. So this is possible, and you see all the detection limits here are below 1 nanogram per liter, which is the requested detection limit. At the moment, we are even much lower now, and we have an option to even inject more if needed. So that's an example here. We did river water near Mülheim, the River Ruhr, which was in the past very, very dirty, but in the last decades it changed. The same institute which provided the water for the European Water Directive research provided this water as well. But you still see that there are some of the PFAS in the range where they're detectable, so quite nice. The RSD here is quite nice, so And the spiked samples, you will see the RSD is even getting better. So less than 20%, all of them, usually less than 16%, which is quite good for this kind of analysis. Yeah? And as soon as it comes to higher ranges, the trueness here is around 100, 80, or between, I would guess, 80 and 100, a little bit above 100 sometimes. And as soon as we go to the 30 nanograms per liter, it's even, the RSD is going down. And the maximum here for PFMBA is 14%, which is, I think this is really quite good. So that's one of the things we've seen, and the trueness here as well. So there's a lot of PFAS we did with this application. Yeah, just going quickly to the results. We got a fully automated LCMS system, online SPE LCMS system. Yeah. Easy sample handling, you place your samples there. The rest is done with the system. There's nothing you have to take care of. You just choose the method, set up your sequence, and the system will know what to do. We have low detection limits and a very good reproducibility. Oops, sorry. No, that's the other way around. So that's what we talked about. The filtration here is not necessary because usually our cartridge will work as a filtration. Even particles in the sample will move through the path until it comes to the cartridge. Yeah? At the cartridge they will stay, and with the last step, with the elution of the cartridge, with the polar effluent, they will be extracted as well again. Yeah? So we have all PFAS which stick to the surface and even to particles can be analyzed. And the cartridge is thrown away later on, so there's no problem with these particles anymore. So there is no filtering up front needed. You can save this step as well. Yeah, I've already talked that's where you have the option to inject even more times, yeah, until the cartridge is just overloaded. That would be a problem. We have never tested this, but the application chemist did 5 milliliters of sample, injecting it, and we lower the detection limits down to less than 0.1 nanogram per liter. We have customers who've done this as well. We'll show you in some of the nice application examples. So we have done a lot of application notes here. They're available at our website, or if you ask Precision Electronics, then they will have them. I guess some of them are already present at your sticks, so there's no need to download it. Just check this one. Yeah, so the latest one we did here, that's the PFAS in water. That Thomas Brunch, who did the talk here, was head of this one. This is the system you already seen. This is a system where he did this application note with. That's the latest system in Mülheim. We have even done the application with the Ultivo system, so the small triple quad. The sensitivity is much lower, but by enriching the samples on our cartridge and exchanging the cartridge, the detection limits are quite low, not as low as with the new LC triple quad, the high-tech, but it's still in the detection limit given, so you can even add this one on an older system, and it should not be a problem to reach the detection limits. Yeah, what I told you, we had a customer here who said if we can do this with water, we're going to try this with PFAS in sludge, compost and soil. And they added their manual sample preparation, that's the first 3 steps, to the MPS. So, and they tried both versions just to confirm that the results are the same. Yeah. So they did the manual cleanup, 50 milliliters of water and 5 milliliter extract. Yeah. And we did the same with a 1 milliliter water and 50 microliter extract. We just scaled it down to see if we can reach the detection limits. Yeah. And the same was done with water here. Half a milliliter of water and half a milliliter of extract and 50 microliter waters. Yeah. So with the online SPE. Sorry, that's the wrong. No, so the results you can just read in the application note. I'm pretty sure that there are some texts around. So that was one of the nice things the customer did for us, because they had this DIN norm here, and they just wanted to see if they can automate it. Yeah? So they did it on their own. So they had the software and everything, they just figured it out, and they came back with the results to us and said, hey, it's working. So we are trusting our customers. Yeah. Then the next step here would be, from water, wastewater, or sludge and compost, whatever soil, people start to ask about PFAS in food. And the first thing we did here, food of animal origin. That's a official governmental site from the department, what is this, lower Saxony, no, not lower Saxony, and Saxony for food, no, for health insurance and veterinarian, whatever. It's in Germany, they mix these ministries. That's a little bit crazy, but they did this team together with Thomas and Brunch and Oliver Lerch from Gerstel did this application note. They had a complex manual sample preparation, which I don't show here, because the most common thing we want to show here is that they compared, after they prepared this extract, they tested it with a Gerstel sampler, an Agilent 90 LC system, and then they handed it over to the Gerstel Spexor system, and in parallel, they used their old system with the Saubergen clip, direct injection with Agilent. And then they compared both. So what was possible with the Gerstel Spexors, we injected about 25 microliters. With the LC of Agilent, we injected directly 2 microliters of this extract to make sure that the peak shape remains the same. And the result was, like expected, around about 12 times lower detection limit at this time. So this customer is now using the system as well. They don't like this direct injection anymore because the sensitivity is much better, and they're transferring now these manual steps to the MPS, but there is one step which means freezing overnight. That doesn't really make sense. So that's something they can't avoid because this is part of the norm they are doing. Okay, this is something that doesn't really make sense to automate this, because waiting for 12 hours at minus 25 degrees is nothing you can hand over to a sampler. Okay, so results from this one here, we have an automated cleanup of food extract. And this means there's a lot of matrix coming with the sample still, even if it's cleaned up before. So, and if you would do this with a pre-column system, then you're overloading your pre-column, and there's no way to wash it correctly. So in our case, we are not trying to wash it. We can try to wash away the matrix. If it's not possible, skip the cartridge, elute it, and just throw it away. That would be an option. Eliminating the matrix would be, or is an advantage, because as soon as the matrix is gone, the detection limits, chromatograph matrix will look much better, and the detection limits drop down again. So this is the big advantage of the system, that you can wash the cartridge, you eliminate the matrix, you can load samples. This is really, then you have a higher amount on the cartridge, and then you can elute, and the detection limits will just drop down. So for this application, the customer came with a detection limit of 0.01 micrograms per kilogram, which is very, very low. The organic wash, that's what we talked about. So compared to the direct injection, much lower detection limits. To compare to the manual SPE, it's much easier to handle, and the reproducibility is very, very good. And compared to the columns, which, we have a much larger flexibility, because this system, as we set it up here and as we ship it, is used for ampha-glyphosate. That's what I know from German customers. We have 4 systems running there. That's why we initially had the idea doing this here. And it can be handled for any kind of samples with pesticides as well. Without changing the setup, you just do an SPE enrichment. Maybe you need to change the cartridge type. That's all. It's a little bit depending on the pesticides you're doing, on the whatever. But it's possible. So you have a very flexible system. Just by changing the cartridge type, maybe that's all you have to do for changing the application. Okay, that's repeating again all these advantages. The advantage at the moment is really that we can handle food samples with a high matrix amount. That's what most of the other vendors cannot do. That's really, and the lower detection is limited by a real enrichment. Okay, that's all for now.
Thank you for the presentation. On va passer à voir quelques questions. Est-ce qu'il y a déjà des gens qui sont intéressés par l'analyse des PFAS? Que ce soit de point de vue analyse, donc des laboratoires, ou de point de vue besoin en tant que client qui demande l'analyse des PFAS. Alors, personne ne s'intéresse aux
Okay,
PFAS.
so anyway, if there are questions shown up, you can ask the team.
I have a small question.
Yeah.
How long it takes before injection to LC, the preparation step? So we are putting our sample onto the cartridge, wait until do the elution, and after that we do injection for the LC column. So this operation, how long it takes, and
So the sample will be placed in the sampler. It will immediately start the conditioning of the cartridge. That's done up front. That's done by this device which is called HPD. After this is done, the sampler will pull up half a milliliter into a syringe, add half a milliliter of water into the syringe, and inject it into the loop. Switch the loop into the SPE cycle, repeating this step 3 times. And then the elution is the step number 4 with the ammonia methanol mixture. So I must admit I don't exactly know. I think about 5 minutes.
5 minutes, not a lot.
But even less. That's a little bit depending. So that's quick and dirty, fast, done. So the most time-consuming step is the elution of the cartridge to make sure that we're not applying too much ammonia to the LC gradient. That's the important part. That has to be mixed correctly, that the pH is not too low, that we have no effect on the first peaks of the PFAS.
OK. Alors, s'il n'y a pas de questions, on vous invite tous à faire une visite au niveau des laboratoires, du laboratoire toxicologie de TTS. Et on peut échanger si vous avez d'autres questions qui concernent l'une des thématiques déjà évoquées la matinée. Alors, on y va? Let's go for the last.
Oh.
Ah, OK. 1 minute. Microplastic and
It's possible. I have it there. If you want to do this, then I can.
OK, I'm just asking. Est-ce qu'il y a quelqu'un qui est intéressé par l'analyse des microplastiques? On peut le voir. OK.
So, wait, the slides are pressed on the sticks.
OK.